The Big Bang did not bang. Silence. That's what filled the void before our universe began. Not a sound. Not a whisper. Not even the concept of silence itself existed. There was no ear to hear, no mind to comprehend, no space for sound waves to travel. The beginning wasn't loud. It was the absolute absence of everything we understand. And yet, here you are, a conscious collection of atoms reading these words, trying to comprehend your own origins. The greatest magic trick in existence. Something from nothing. Everything, from the device you're using to the thoughts forming in your mind, emerged from what appears to be absolute nothingness. The ultimate violation of the most fundamental principle we know. Nothing comes from nothing. But what if everything we think we know about nothingness is wrong? What if the very concept of nothing is the greatest illusion in the cosmos? Take a breath. Feel the air filling your lungs. This seemingly simple act connects you to the greatest mystery in existence. The oxygen entering your bloodstream was forged in the heart of a star that exploded billions of years ago. The carbon in your cells was created in cosmic furnaces that no longer exist. You are, quite literally, made of stardust. But where did those stars come from? Where did the laws that govern their formation originate? And what existed before the first spark of creation? If you could rewind time, watch galaxies unform, stars implode in reverse, matter condense back into a primordial point, what would you see at the beginning? A cosmic architect drawing blueprints? A random quantum fluctuation? Or something beyond our comprehension entirely? For centuries, we've told ourselves comforting stories about our origins. Ancient myths spoke of cosmic eggs hatching, divine beings stirring, primordial waters parting. Modern cosmology gives us the Big Bang. A singular moment of creation when space, time, matter, and energy burst into existence from an infinitely dense, infinitely hot singularity. But this scientific origin story contains a haunting implication. Everything, all matter, energy, space, and time itself, emerged from what appears to be nothing at all. Imagine standing at the edge of the observable universe. Now imagine taking one step further. What would you find? More universe? A boundary? A wall with end of reality graffitied across it? Our minds recoil at the possibility of true nothingness. We cannot visualize it, cannot model it mathematically, cannot even properly conceive it. Nothing is not empty space. Empty space is still something governed by physical laws, rippling with quantum fields, expanding through time. True nothingness would have no dimensions, no properties, no potential, no laws, no time, not even emptiness, not even void. And yet, here we are, existing, thinking, wondering. The creation of something from nothing violates every intuition we possess. It defies the conservation laws that govern our reality. It challenges the very foundation of rational thought. And yet, the evidence of our existence forces us to confront an impossible choice. Either something can emerge from nothing, or what we call nothing is not truly nothing at all. Close your eyes for a moment. Try to imagine absolute nothingness. Not darkness. Darkness is something. Not emptiness. Emptiness is a space waiting to be filled. Not even a void. A void has dimensions, has existence. Try to imagine the complete absence of everything. No space, no time, no potential, no rules, no existence itself. You can't do it, can you? Your mind fills the emptiness with something. a dark space, a blank canvas, a theater of potential. This isn't a failure of imagination. It's a clue, perhaps the most important one in our cosmic investigation. What if our inability to conceive of true nothingness isn't a limitation of human cognition, but an insight into the nature of reality itself? What if true nothingness cannot exist, not just practically, but logically, fundamentally, necessarily? The ancient Greeks had a word for it: chaos. Not disorder as we understand it today, but the formless void that preceded creation. The primordial potential from which reality emerged. Modern physicists speak of quantum vacuum, not empty space, but a seething ocean of virtual particles popping in and out of existence, borrowing energy from the future, repaying it before it comes due. Philosophers debate the concept of non-being, questioning whether nothing is even a coherent concept in the first place. And here, at the intersection of ancient wisdom, cutting-edge physics, and philosophical paradox, we find ourselves confronting the most disturbing possibility of all. What if nothing never existed? What if the cosmos, all of reality, all of existence, is fundamentally, necessarily, eternally something? You might wonder why this matters. After all, you have bills to pay, relationships to nurture, a life to live. What difference does it make whether the universe emerged from nothing, whether true nothingness can exist, whether reality had a beginning at all? But this isn't just abstract philosophy. It's the foundation of everything we know, everything we are, everything we might become. Our understanding of cosmic origins shapes our view of human purpose, of moral responsibility, of the meaning of life itself. If we emerged from nothing, through random processes, for no reason, that tells us something profound about our place in the cosmos. If we are instead the necessary expression of an eternally existing reality, that tells us something else entirely. The story of cosmic creation isn't just about what happened 13.8 billion years ago. It's about what's happening now, in this moment. As the universe continues to unfold, as complexity emerges from simplicity, as conscious beings like you contemplate their own existence, it's about what might happen in the distant future. As entropy increases, as stars burn out, as the cosmos approaches its final state, whatever that might be. Let's journey backward in time, to the earliest moment we can comprehend. Not the Big Bang itself. That name is misleading. There was no explosion, no bang, no sound at all. Instead, imagine the entire observable universe compressed into a volume smaller than an atom. Every galaxy, every star, every planet, every particle of matter that would ever exist, all occupying an infinitesimal point. All the energy that would ever power cosmic evolution, all the space that would ever separate celestial bodies, all the time that would ever pass, all compressed into a singularity of infinite density, infinite temperature, infinite curvature. Our ATE mathematical models break down at this point. The laws of physics as we understand them cease to function. General relativity, which describes gravity and the large-scale structure of the universe, cannot be reconciled with quantum mechanics, which describes the behavior of matter and energy at the smallest scales. At the moment of the Big Bang, both sets of laws would apply, and yet they contradict each other. This isn't just a gap in our knowledge. It's a sign that our most fundamental theories about reality are incomplete, perhaps even fundamentally flawed. What existed before this singularity? Physics cannot tell us. Time itself began at the moment of the Big Bang. Asking what came before might be like asking what's north of the North Pole. The question itself might be meaningless. And yet, human curiosity demands an answer. Our minds rebel against the notion that reality simply began, without cause, without precursor, without explanation. Some theorists propose that our universe emerged from a quantum fluctuation in a pre-existing state, perhaps a quantum vacuum, perhaps another universe with different physical laws. Others suggest that the Big Bang was just one of many, a single breath in the endless respiration of a cyclical cosmos, expanding and contracting eternally. Still others propose that time itself is an emergent property, not a fundamental feature of reality, that the question of before is based on a misunderstanding of the nature of temporality. But all these theories must eventually confront the fundamental question: why does anything exist at all? Why is there something rather than nothing? This question, first posed by Gottfried Wilhelm Leibniz in the 17th century, haunts physics, philosophy, and theology to this day. It might be the only question that truly matters, the question upon which all other questions depend. Imagine for a moment that true nothingness were possible, that reality could, in principle, be completely devoid of existence. No matter, no energy, no space, no time, no laws, no potential. If such a state were possible, why isn't it actual? What compelled existence to emerge? What selected something over nothing? The principle of sufficient reason suggests that there must be an explanation for why reality is the way it is rather than some other way. But what could possibly explain the existence of everything? One of the most disturbing possibilities is that there is no explanation, that existence is a brute fact, uncaused, unexplained, unintelligible, that the question, why is there something rather than nothing, has no answer at all. This possibility offends our sense that reality should be comprehensible, that the cosmos should make sense, that existence should have a reason. But our offense doesn't make it false. Reality is under no obligation to conform to human expectations of intelligibility. Alternatively, perhaps existence is necessary. Perhaps reality couldn't have been otherwise. Perhaps the concept of absolute nothingness is logically incoherent, a philosophical mistake rather than a genuine possibility. Perhaps being is the default state, and non-being is what would require explanation, an explanation that cannot be given because non-being is impossible. In principle, consider this: every attempt to imagine or define nothingness involves the negation of something. No thing. Not being. The absence of existence. These concepts are parasitic on the concepts they negate. We can only conceive of nothing in relation to something. What if this isn't just a linguistic or psychological limitation, but an ontological one? What if nothingness cannot exist because existence itself is primary, fundamental, inescapable? Look around you. The device you're using to access this video, the air you're breathing, the thoughts forming in your mind, all of it exists. All of it is part of an unbroken chain of causality, stretching back to the earliest moments of the cosmos. And yet, physics tells us that the total energy of the universe might be precisely zero, that the positive energy of matter is exactly balanced by the negative energy of gravitational attraction. In a profound sense, the universe might be nothing. After all, a perfect symmetry, a zero-sum game, a cosmic accounting error that somehow produced stars and planets, and conscious beings capable of pondering their own existence. What if the question itself is flawed? What if we're caught in a false dichotomy between absolute something and absolute nothing? What if reality is neither something nor nothing, but a third option our limited minds cannot grasp? What if the fundamental nature of existence transcends these categories entirely? The history of science is filled with such category errors, questions that couldn't be answered because they were based on fundamental misunderstandings. Before Einstein, physicists debated the properties of the luminiferous ether, the medium through which light waves were thought to propagate. Einstein didn't solve this problem. He dissolved it, showing that no such medium was necessary, that the question itself was based on a flawed understanding of the nature of light and space-time. What if the question, why is there something rather than nothing, will meet a similar fate, not answered, but transcended by a deeper understanding of the nature of reality? Consider the quantum vacuum, the ground state of a quantum field. It's not nothing. It contains energy, structure, potential. Virtual particles pop in and out of existence, borrowing energy, repaying it before the cosmic accountant notices the discrepancy. Empty space seethes with activity at the quantum level. What we perceive as nothing is actually something, a complex, dynamic system governed by physical laws. But this just pushes the question back. Where did the quantum vacuum come from? Where did the laws that govern it originate? Why does quantum mechanics work the way it does rather than some other way? We find ourselves in an infinite regress, each answer spawning new questions, each solution creating new puzzles. Perhaps the most vertigo-inducing possibility is that reality is fundamentally mathematical, that physical existence is actually a mathematical structure, and that structure exists necessarily, inevitably, eternally. In this view, championed by physicists like Max Tegmark, the universe isn't described by mathematics, it is mathematics. And mathematical truths exist necessarily. They couldn't be otherwise. 2 plus 2 must equal 4. It couldn't be 5, or 3, or p. If reality is mathematical at its core, perhaps its existence is similarly necessary, not contingent, not caused, not created, but logically inevitable. But even this view must confront the question, why these mathematical structures, rather than others? Why these physical laws, these fundamental constants, these initial conditions? Our universe seems fine-tuned for complexity, for life, for consciousness. The values of fundamental constants, like the strength of gravity, the mass of the electron, the cosmological constant, appear precisely calibrated to allow for the emergence of stars, planets, and biochemistry. Alter these values by a fraction of a percent, and the universe becomes sterile, either collapsing immediately after the Big Bang, or expanding so rapidly that matter never forms structures, or producing a chemistry too simple for life to emerge. This fine-tuning suggests either an incredible cosmic coincidence, a multiverse of infinite possibilities where we naturally find ourselves in a life-permitting region, or some form of purposeful calibration. None of these options is intellectually comfortable. All stretch our understanding to the breaking point. All remind us of how little we truly comprehend about the nature of existence. And here we arrive at perhaps the most disturbing possibility of all. What if the question itself is meaningless? What if, why is there something rather than nothing, is a linguistic illusion, a grammatically valid but semantically empty string of words? What if we're asking about the cause of causality itself, the explanation for explanation, the reason for reason? What if we're caught in a conceptual loop from which there is no escape, like a dog chasing its tail, like a computer program running in an infinite recursive function? The philosopher Ludwig Wittgenstein suggested that many philosophical problems arise from the misuse of language, from applying concepts outside their proper domain, from asking questions that appear meaningful but actually contain category errors or hidden contradictions. What if the question of cosmic origins is such a pseudo-problem, not a mystery to be solved, but a confusion to be dissolved. Consider, when we ask why something exists, we're implicitly applying causal reasoning. We're looking for a prior condition, a mechanism, a process that brought the thing into being. But if we're asking about the existence of everything, including causality itself, then causal reasoning can't apply. We're trying to stand outside of existence to explain existence, outside of causality to explain causality. The attempt itself might be incoherent. And yet, the question haunts us. We cannot easily dismiss it as meaningless, cannot comfortably accept that the most fundamental fact of our existence, that there is existence at all, might be unintelligible, unexplainable, a brute fact without reason or cause. Our minds rebel against this possibility. We search for meaning, for pattern, for explanation. It's what makes us human. It's what drives science, philosophy, religion, our desperate, beautiful attempt to make sense of a reality that might, at its core, transcend. Sense-making itself. Look up at the night sky. Each point of light is a sun, many larger and brighter than our own. Many are orbited by planets, some rocky, some gaseous, some perhaps harboring life, consciousness, civilizations asking the same questions we ask. The visible stars are just a fraction of our galaxy, which contains hundreds of billions of stars, and our galaxy is just one among hundreds of billions in the observable universe. And the observable universe might be just a tiny fraction of the actual cosmos, most of which lies beyond the horizon of our perception, expanding faster than light can travel, forever invisible to us. And all of this, every star, every planet, every galaxy, every atom, every quantum field, every physical law, emerged from what appears to be nothing at all. Or did it? What if nothing never existed? What if existence is the default state, and nothingness is the true impossibility? What if the question itself is wrong? Not just difficult, not just currently unanswerable, but fundamentally misconceived. Perhaps we're asking, why is there something rather than nothing? When we should be asking, why do we think nothing is possible in the first place? What if the concept of absolute nothingness is the true illusion, a phantom conjured by language, by our limited cognitive architecture, by our evolved tendency to think in terms of objects against backgrounds, figures against grounds, things within space? In the quantum realm, particles don't simply exist or not exist. They exist in superpositions of states, their properties indeterminate until measured. The vacuum isn't empty. It's filled with fields, with potential, with virtual particles popping in and out of detectable reality. In the realm of consciousness, subjective experience doesn't simply occur or not occur. It exists in degrees, in modes, in qualities that defy binary categorization. In mathematics, infinity isn't simply larger than any finite number. There are different orders of infinity, some infinitely larger than others, forming a hierarchy of endlessness that challenges our most fundamental intuitions about size and quantity. What if existence itself is similarly non-binary? What if the distinction between being and non-being is an oversimplification, a useful fiction, rather than a fundamental feature of reality? What if existence comes in degrees, in modes, in forms that transcend simple categorization? What if the universe didn't emerge from nothing, but transformed from one mode of existence to another, from a state we cannot comprehend to the reality we observe? The history of human understanding is a history of expanding conceptual categories. Once, we thought in terms of earth, air, fire, and water. Then we discovered elements, compounds, atoms, subatomic particles, quantum fields. Once we thought in terms of past, present, and future, as absolute categories. Then Einstein showed us that simultaneity is relative, that the flow of time depends on motion and gravity, that the distinction between past and future blurs at the quantum scale. Once, we thought of space as an empty stage upon which matter performs its dance. Then we discovered that space itself is dynamic, that it curves in the presence of mass, that it expands as the universe evolves. Perhaps the distinction between something and nothing will meet a similar fate, not reinforced by deeper understanding, but transcended, dissolved, revealed as a useful approximation rather than a fundamental truth. Perhaps future physics, future mathematics, future philosophy will give us new conceptual tools, new categories, new ways of thinking that make the question, why is there something rather than nothing, as obsolete as questions about the composition of phlogiston or the mechanics of animal spirits. But until that day arrives, if it ever does, we remain haunted by the apparent miracle of existence, by the fact that reality exists at all, by the mystery of how anything could emerge from nothing, or why nothing never was. This haunting is not a weakness. It's not a failure of understanding. It's the proper response to the most profound enigma we confront, the sheer fact that there is something to question, something to know, something to be. Look again at the night sky. Each photon entering your eye has traveled for years, decades, centuries, millennia, carrying information from distant suns, from ancient cosmic events, from the earliest moments of the universe itself. Those photons have journeyed across vacuum, not true nothingness, but space itself, the cosmic medium that both separates and connects all things. As you perceive those photons, as your brain processes the information they carry, as your mind contemplates the vastness they reveal, you're not separate from this cosmic process. You're part of it, a node in the universal network, a momentary configuration of matter and energy that has become aware of itself, that has begun to question its own origins, that has developed the capacity to wonder why there is something rather than nothing. And in that wonder, in that questioning, in that capacity for awe in the face of existence, perhaps we glimpse the beginnings of an answer, not a final explanation, not a complete account, but a clue. A suggestion that consciousness itself might be involved in the answer. That awareness might not be merely a late-arriving spectator to cosmic evolution, but somehow integral to existence itself. That the capacity to ask, why is there something rather than nothing, might be connected to the reason there is something rather than nothing. This isn't to suggest a simple anthropocentric answer, that the universe exists so that we might exist, that human consciousness is the purpose of cosmic evolution. Such an explanation would be both narcissistic and circular, explaining the existence of everything in terms of a tiny, recent, possibly transient phenomenon within that everything. But it is to suggest that consciousness, awareness, subjectivity might be more fundamental to reality than we typically assume, not merely a product of complex neural activity, but an expression of something intrinsic to existence itself. Quantum mechanics hints at this possibility. The observer effect, the fact that the act of measurement influences the system being measured, suggests a profound entanglement between consciousness and physical reality. The delayed choice experiments, in which measurements made in the present appear to influence events in the past, challenge our linear conception of causality. The phenomenon of quantum entanglement, in which particles separated by vast distances behave as a single system, defies our intuitive understanding of space itself. None of these phenomena prove that consciousness creates reality, or that the universe requires observers to exist, but they do suggest that the relationship between mind and matter, between observer and observed, between consciousness and physical reality, is more complex, more intimate, more mysterious than classical physics led us to believe. They hint at a cosmos in which consciousness is not merely an epiphenomenon, a side effect of complex information processing, but somehow woven into the fabric of reality itself. Ancient wisdom traditions have long suggested similar possibilities. The Vedantic concept of Brahman, the ultimate reality underlying all existence, simultaneously transcendent and immanent. The Buddhist notion of sunyata, emptiness, the lack of inherent existence in all phenomena, the dependent co-arising of all things. The Taoist principle of wu-wei, non-action, the recognition that the fundamental nature of reality transcends the categories of being and non-being, action and inaction, something and nothing. These traditions don't provide scientific explanations for the existence of the universe. They don't offer mathematical models or empirical predictions, but they do suggest conceptual frameworks, ways of thinking, modes of understanding that might help us approach the question of cosmic origins from new angles, with fresh perspectives, free from the conceptual limitations that might be constraining our current attempts at explanation. What if nothing never existed? What if something, existence, reality, being, is the default state, the necessary condition, the inescapable foundation of everything? What if the question, why is there something rather than nothing, assumes a possibility, absolute nothingness, that never was and never could be? What if the mystery isn't how something emerged from nothing, but why we ever thought nothing was an option in the first place? These aren't comforting answers. They don't provide the closure, the finality, the sense of completion that our minds crave. They don't allow us to close the book on the mystery of existence, to file it away as a solved problem, to move on to other questions. But they might offer a path forward, a way of approaching the mystery that doesn't lead to logical contradictions, infinite regress, or conceptual dead ends. The universe didn't begin with a bang. It didn't emerge from true nothingness. It exists, has always existed, will always exist, in forms, in modes, in manifestations that evolve, that transform, that progress from states of lower entropy to higher entropy, from simplicity to complexity, from potentiality to actuality. The Big Bang wasn't the beginning of existence, but a phase transition, a transformation from a state we cannot observe, cannot model, cannot comprehend, to the expanding, cooling, evolving cosmos we inhabit. This perspective doesn't answer all our questions. It doesn't explain why the universe has the particular physical laws it has, why the fundamental constants have the values they do, why initial conditions were what they were. It doesn't tell us whether our universe is unique or one among many, whether space-time is fundamental or emergent, whether consciousness plays a role in the deepest levels of reality. But it does suggest that the apparent miracle of existence, the emergence of something from nothing, might not be a miracle at all. It might be a misconception, a category error, a result of our limited conceptual framework rather than a feature of reality itself. And in that recognition, that the problem might lie in our thinking rather than in the cosmos, we find both humility and hope. Humility, because we acknowledge the limitations of our understanding, the constraints of our cognitive architecture, the boundary conditions of human comprehension. Hope, because we glimpse the possibility of progress, of conceptual evolution, of new frameworks that might dissolve the mystery rather than solving it within our current paradigm. Look once more at the night sky. Feel the cosmic rays passing through your body. Particles born in distant supernova, journeying across vacuum for millions of years, penetrating your cells, interacting with your atoms. Consider the dark matter surrounding you. Invisible, detectable only through its gravitational effects, comprising far more of the universe's mass than all visible matter combined. Contemplate the dark energy permeating space, the mysterious force accelerating cosmic expansion, pushing galaxies away from each other at ever-increasing speeds, dominating the large-scale evolution of the universe. None of this emerged from true nothingness. All of it exists, has always existed, will always exist, in forms, in states, in manifestations that evolve, that transform, that transcend our limited categories of being and non-being, something and nothing, existence and void. The mystery isn't how something came from nothing. The mystery is why we ever thought nothing was possible in the first place. As we journey deeper into the cosmos, as we probe the earliest moments of the universe, as we develop new mathematics, new physics, new philosophy, new ways of thinking, we may find that the question, why is there something rather than nothing, takes on new forms, reveals new dimensions, opens new pathways to understanding. We may discover that the apparent contradiction between eternal existence and temporal beginning dissolves in a deeper understanding of the nature of time itself. We may find that the seeming paradox of necessary contingency, the fact that the universe appears simultaneously inevitable and arbitrary, resolves in a more comprehensive theory of physical law and cosmic evolution. Or we may discover that the mystery deepens, that the enigma of existence becomes more profound, more perplexing, more resistant to explanation. The more we learn, the further we probe, the deeper we think. We may find that consciousness itself, the capacity to ask, why is there something, rather than nothing, is not merely a product of cosmic evolution, but somehow integral to the answer, not merely a late arising phenomenon, but a clue to the nature of reality itself. And in that discovery, whether it leads to resolution or deeper mystery, we fulfill our cosmic role. We become the universe questioning itself, existence contemplating its own nature, the cosmos achieving self-awareness through the temporary configuration of matter and energy that we call humanity. We become not merely spectators to cosmic evolution, but participants, conscious nodes in the universal network, momentary expressions of the universe's capacity for self-reflection, transient embodiments of existence's potential for self-understanding. The Big Bang did not bang. There was no sound, no explosion, no emergence from true nothingness. There was transformation, evolution, becoming, the universe-changing state, transitioning phase, manifesting potential. And in that process, ongoing, eternal, encompassing all of space and time, we find ourselves questioning, wondering, existing, part of the cosmic process, not separate from it, expressions of the universe's nature, not aliens within it, temporary, configurations of matter and energy that have achieved the capacity to contemplate their own origins, to question their own existence, to wonder why there is something rather than nothing. And in that wondering, in that questioning, in that contemplation, we glimpse not the answer, but the path toward it, not the solution, but the journey, not the explanation, but the process of seeking it. And that process itself, the evolution of understanding, the development of new conceptual frameworks, the transcendence of old categories, might be the closest we can come to resolving the mystery of existence. Not by finding a final answer within our current paradigm, but by evolving new paradigms, new ways of thinking, new modes of understanding that transform the question itself. What if nothing never existed? What if something, existence, reality, being, is the default state, the necessary condition, the inescapable foundation of everything? What if the question, why is there something rather than nothing, assumes a possibility, absolute nothingness, that never was and never could be? What if the mystery isn't how something emerged from nothing, but why we ever thought nothing was an option in the first place? These aren't answers. They're invitations to think differently, to question our assumptions, to explore new conceptual territories, to evolve our understanding of the most fundamental mystery we confront, the sheer fact of existence itself. And in that invitation, in that exploration, in that evolution, perhaps we find not resolution, but progress. Not certainty, but growth. Not an end to questioning, but a deepening of the questions themselves. The cosmos wasn't created from nothing. It exists, has always existed, will always exist, in forms, in modes, in manifestations that evolve, that transform, that transcend our categories of being and non-being, something and nothing, existence and void. And we are part of that cosmos, not separate from it. Expressions of its nature, not aliens within it. Temporary configurations of matter and energy that have achieved the capacity to contemplate their own origins, to question their own existence, to wonder why there is something rather than nothing. And in that wondering, in that questioning, in that contemplation, we fulfill our cosmic role. We become the universe questioning itself, existence contemplating its own nature, the cosmos achieving self-awareness through the temporary configuration of matter and energy that we call humanity. We become not merely spectators to cosmic evolution, but participants, conscious nodes in the universal network, momentary expressions of the universe's capacity for self-reflection, transient embodiments of existence's potential for self-understanding. The Big Bang did not bang, and nothing never was. We live in a universe that is 13.8 billion years old. This is one of the most secure facts in modern cosmology, a cornerstone of our scientific understanding, measured with remarkable precision through multiple independent methods. The cosmic microwave background radiation, the abundance of light elements, the distribution of galaxies across space all point to the same answer. 13.8 billion years. The age of everything. But what does that number actually mean? When we say the universe is 13.8 billion years old, we're not simply stating how long it has existed. We're making a profound claim about the nature of time itself. We're saying that time, the dimension in which cause precedes effect, in which entropy increases, in which you were born before you die, had a beginning. Not just the matter within the universe, not just the energy, not just the galaxies and stars and planets, but time itself came into existence 13.8 billion years ago. Think about that for a moment. Not the beginning of something within time, but the beginning of time itself. Our minds rebel against this concept. We instinctively want to ask, what happened before the beginning of time? What caused time to start? But these questions presuppose that time already existed, that there was a before in which causes could operate. The beginning of time wasn't an event that occurred at a particular moment. It was the beginning of moments themselves. The question, what happened before time began, might be as meaningless as asking, what's north of the North Pole? And yet, our mathematical models of cosmic evolution, the equations of general relativity that describe the expansion of space-time, track backward to a singularity, a point of infinite density and temperature where the laws of physics themselves break down. This singularity isn't a physical object in space. It's a boundary of our mathematical description, a place where our current theories fail us. The singularity isn't something that existed 13.8 billion years ago. It's the edge of time itself, the limit of our ability to describe reality using the language of modern physics. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. Space and time were so compressed, so distorted by extreme energy densities, that the distinction between past and future, between here and there, became meaningless. The fabric of reality was compressed to a state of pure potential, a cosmic seed containing all the energy, all the matter, all the physical laws that would ever exist. Imagine standing on the surface of a sphere. You can walk in any direction, north, south, east, west, and never find an edge, never reach a boundary. The sphere is finite, yet unbounded. Now add a dimension. Imagine the surface of the sphere expanding in all directions simultaneously, every point moving away from every other point. This is the geometry of our expanding universe, finite yet unbounded, expanding yet centerless. The Big Bang didn't happen at a particular location in pre-existing space. It happened everywhere at once, at every point in what would become our universe. If you were to rewind this cosmic expansion, to run the film of universal evolution backward, you wouldn't see matter collapsing toward a central point in empty space. You would see space itself contracting, the distance between any 2 points diminishing, the volume of the cosmos reducing toward zero. The Big Bang wasn't an explosion of matter into empty space, it was an expansion of space itself, carrying matter and energy along with it. This distinction is crucial, yet counterintuitive. We're accustomed to thinking of events occurring within space and time, an explosion that happens at a particular location, at a particular moment. But the Big Bang wasn't an event within space-time, it was the origin of space-time itself, not an explosion in pre-existing emptiness, but the beginning of the possibility of location, of distance, of duration. Look up at the night sky. Every point of light you see, every star, every galaxy, is moving away from us. And the farther an object is from us, the faster it's receding. This isn't because we're at the center of some cosmic explosion. It's because space itself is expanding, stretching like the surface of an inflating balloon. From any galaxy in the universe, the view would be the same. All other galaxies appearing to move away, with the most distant receding the fastest. This expansion has profound implications. It means that in the distant past, everything was closer together. The entire observable universe, all 93 billion light-years of it, was once compressed into a volume smaller than an atom. The vast cosmic distances that now separate galaxies were once infinitesimal. The emptiness of intergalactic space, stretches of vacuum millions of light-years across, was once non-existent. But here we encounter a paradox. If the universe has no edge, then where does it begin? If space itself is expanding, what is it expanding into? Our intuition demands a boundary, a frontier, a demarcation between what exists and what doesn't. But cosmic geometry defies this. Intuition. The universe might be infinite, extending without limit in all directions, containing an infinite number of galaxies, an infinite amount of matter and energy. Or it might be finite yet unbounded, like the surface of a higher dimensional sphere containing a finite amount of matter and energy, yet having no edge, no boundary, no outside. In either case, infinite or finite yet unbounded, the universe doesn't expand into anything. It simply expands. The distance between galaxies increases, but there's no beyond into which the universe is growing. There's no edge of the cosmos rushing outward into pre-existing emptiness. There's only space itself stretching, carrying galaxies along with it, like dots on an expanding balloon. This cosmic expansion isn't merely a historical fact about the early universe, it's ongoing. And not only is it ongoing, it's accelerating. The rate of expansion is increasing with time, driven by a mysterious force called dark energy. The nature of this dark energy, which comprises approximately 68% of the total energy content of the universe, remains one of the greatest unsolved problems in modern physics. We know it exists, we can measure its effects, but we don't know what it is. Think about that. The majority of the energy in the cosmos, the dominant factor determining its ultimate fate, is something we cannot explain, cannot directly detect, cannot even properly conceive within our current theoretical framework. Dark energy isn't just another mystery among many. It's a sign that our understanding of fundamental physics remains profoundly incomplete. And dark energy isn't the only cosmic mystery that haunts our models. Approximately 27% of the universe consists of dark matter, a substance that interacts gravitationally with ordinary matter but doesn't emit, absorb, or reflect light. We can't see it, can't touch it, can't directly detect it with our instruments. We know it exists only through its gravitational effects, its influence on the rotation of galaxies, on the bending of light around massive objects, on the formation of large-scale cosmic structures. Together, dark energy and dark matter comprise approximately 95% of the cosmos. The ordinary matter that forms stars, planets, and living beings, everything we can see, touch, and directly interact with, represents just 5% of the universe's total content. Our direct experience of reality, the subject of all our scientific instruments, the focus of centuries of careful observation and experiment, reveals just a tiny fraction of what exists. Consider what this means. Our most advanced theories, our most sophisticated models, our most precise measurements, all based on this 5% of reality, might be as limited as a theory of Earth's climate developed by studying only the Arctic, or a theory of human behavior, based solely on the activities of sleeping people. We're trying to understand the cosmos based on a tiny, possibly unrepresentative sample of its contents. And yet, despite these limitations, we've developed a remarkably successful model of cosmic evolution, the Lambda CDM model, or Standard Model of Cosmology. This model describes the expansion history of the universe from a fraction of a second after the Big Bang to the present day, accurately predicting the abundance of light elements, the properties of the cosmic microwave background radiation, the large-scale distribution of galaxies, and many other observed phenomena. But this success comes with a caveat. The Standard Model doesn't explain what caused the Big Bang. It doesn't tell us why the universe began in a state of extremely low entropy, highly ordered, like a wound-up cosmic spring ready to uncoil. It doesn't explain why the fundamental constants of nature, the strength of gravity, the mass of the electron, the speed of light, have the particular values they do. Values that appear fine-tuned to allow for the emergence of complexity, of stars, of life. These are not minor issues, not loose ends to be tidied up later. They are fundamental gaps in our understanding, signs that our most successful theories are, at best, incomplete approximations of a deeper reality we have yet to grasp. Consider the inflationary model, a refinement of the Big Bang theory that proposes an incredibly rapid expansion of space in the first fraction of a second of cosmic history. This model solves several problems with the original Big Bang theory, explaining why the universe appears flat, why the cosmic microwave background is so uniform, why we don't observe magnetic monopoles or other exotic relics from the early universe. But inflation raises as many questions as it answers. What caused this explosive expansion? What provided the energy that drove it? What determined when it would end? The inflationary model adds a new chapter to the cosmic story, but it doesn't provide a complete narrative. It pushes the mystery of origins back a step, from the Big Bang itself to the conditions that gave rise to inflation. And what about the multiverse? The proposition that our universe is just one among many, perhaps infinitely many, each with its own physical laws, its own fundamental constants, its own cosmic history? This isn't merely science fiction. It's a serious proposal that emerges from several different theoretical frameworks, including eternal inflation, string theory, and quantum mechanics. The multiverse hypothesis is scientifically seductive. It offers a potential explanation for the apparent fine-tuning of our cosmos, the fact that the fundamental constants of nature seem precisely calibrated to allow for complexity, for life, for consciousness. If there are infinitely many universes with different physical laws, then of course, we find ourselves in one that permits our existence. No divine calibration required, no cosmic purpose necessary, just the anthropic principle at work. We observe a life-permitting universe because only in such a universe could observers evolve to make observations. But the multiverse hypothesis comes at a high epistemological cost. It posits entities, other universes, that are by definition unobservable from within our universe. It makes claims about reality that cannot, even in principle, be empirically verified or falsified using the methods of science as traditionally practiced. It threatens to replace the empirical foundation of physics with a meta-empirical approach, one that values mathematical consistency and explanatory power over direct observational evidence. This tension between empiricism and the limits of observation, between explanation and verification, between scientific reach and methodological constraint, isn't merely an academic concern. It's a sign that we're approaching the boundaries of science as traditionally conceived, that we're confronting questions that may require new methodologies, new epistemologies, new ways of knowing. The universe is not simply stranger than we imagine. It is stranger than we can imagine. This phrase, often attributed to biologist J.B.S. Haldane, captures a profound truth about cosmic reality. The universe doesn't conform to human expectations, doesn't respect human intuitions, doesn't operate within the constraints of human conceptual categories. It is what it is, regardless of our ability to comprehend it. Consider quantum mechanics, our most successful theory of the fundamental nature of matter and energy, a theory that has been experimentally verified to an astonishing degree of precision. According to quantum mechanics, particles don't have definite properties until measured. They exist in superpositions of states, simultaneously embodying multiple, sometimes contradictory conditions. They can be entangled across vast distances, their properties correlated in ways that seem to violate our understanding of locality and causality. These quantum phenomena aren't merely counterintuitive, they're seemingly incomprehensible within our ordinary conceptual framework. Particles that are both here and there until observed. Cats that are both alive and dead until the box is opened. Information that appears to travel instantaneously across cosmic distances in seeming violation of the cosmic speed limit set by the velocity of light. Physicists have developed mathematical formalisms that predict the outcomes of quantum experiments with extraordinary precision. But what these equations actually mean, what they tell us about the fundamental nature of reality, remains a subject of intense debate more than a century after the development of quantum theory. Do particles truly lack definite properties until measured, as the Copenhagen interpretation suggests? Or do all possible measurement outcomes occur in parallel universes, as the many worlds interpretation proposes? Or is quantum mechanics merely an approximation of a deeper theory, one that would restore determinism and locality, as Einstein hoped. We don't know. We may never know. The universe doesn't owe us explanations that fit comfortably within our cognitive architecture, and quantum weirdness isn't confined to the microscopic realm. Quantum effects scale up, influencing macroscopic phenomena. Superconductivity, superfluidity, quantum computing, all depend on quantum behavior manifest at scales visible to the naked eye. The boundary between the quantum and classical worlds isn't a matter of size but of interaction, of entanglement with the environment. In principle, quantum superposition could apply to objects of any size, even, theoretically, to conscious observers. This raises profound questions about the relationship between consciousness and physical reality. In the traditional Copenhagen physics interpretation of quantum mechanics, measurement, the interaction between an observer and a quantum system causes the collapse of the wave function, the resolution of quantum superposition into a single definite state. But what constitutes a measurement? What qualifies as an observer? Does consciousness play a role in the manifestation of definite reality from quantum potential? These questions aren't merely philosophical, they're scientific. They influence how we interpret experiments, how we design new investigations, how we understand the nature of reality itself. And they suggest a universe far stranger, far more mind-bending than our intuitions prepared us to comprehend. Now consider general relativity, Einstein's theory of gravity, which describes space-time as a dynamic, curved manifold whose geometry is determined by the distribution of matter and energy. According to general relativity, gravity isn't a force propagating through space-time. It is space-time warped and distorted by mass and energy. This theory has been confirmed by numerous observations. The precession of Mercury's orbit, the bending of starlight around the Sun, the gravitational redshift of light, the existence of black holes, the detection of gravitational waves. General relativity isn't merely a useful approximation. It's a profound insight into the nature of space, time, and gravity. But general relativity, like quantum mechanics, challenges our intuitions. It tells us that time isn't absolute, that simultaneity depends on the observer's reference frame, that the flow of time slows in strong gravitational fields or at high velocities. It tells us that space and time aren't merely the stage upon which cosmic events unfold, but dynamic participants in those events, stretching, contracting, warping in response to matter and energy. And here we encounter a fundamental problem in modern physics. General relativity and quantum mechanics, our two most successful physical theories, are incompatible. General relativity describes gravity as the curvature of space-time, a smooth, continuous manifold. Quantum mechanics describes matter and energy in terms of discrete quanta, probabilistic behavior, and quantum fields. These descriptions work brilliantly in their respective domains, general relativity for the very large, quantum mechanics for the very small, but they cannot both be fundamental. One or both must be approximations of a deeper theory, a theory of quantum gravity that would unify our understanding of all four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. The search for this unified theory, sometimes called a theory of everything, has occupied the greatest minds in physics for decades. String theory, loop quantum gravity, causal set theory, asymptotic safety, causal dynamical triangulations, all attempt to reconcile quantum mechanics with general relativity to provide a consistent theoretical framework that would describe all fundamental forces, all particles, all interactions. But despite tremendous intellectual effort, despite sophisticated mathematical techniques, despite ingenious theoretical insights, we still lack a complete, experimentally verified theory of quantum gravity. This gap in our understanding isn't merely a technical issue, a puzzle to be solved through more advanced mathematics or more precise experiments. It's a sign that our conceptual foundations may be inadequate, that our fundamental understanding of space, time, matter, and energy may require radical revision. Consider what happens at the beginning of the universe, or at the center of a black hole, regions where both quantum effects and gravitational effects become dominant. Our current theories break down. Mathematical infinities appear in our equations. Our ability to describe reality using the language of modern physics reaches its limit. These singularities, points where our theories fail, aren't merely annoying exceptions. They're profound clues. They tell us that something is missing in our understanding, that our current conceptual framework is incomplete. They're like the anomalies in celestial mechanics that led to the discovery of Neptune, or the peculiarities in atomic spectra that led to the development of quantum mechanics. They're not obstacles to progress. They're signposts pointing toward deeper understanding. And this brings us back to the age of the universe, that seemingly precise figure of 13.8 billion years. This number emerges from our current theoretical framework, from the equations of general relativity applied to an expanding cosmos filled with matter, radiation, dark matter, and dark energy. It tells us how much time has elapsed since the universe was in a state of extreme density and temperature. But it doesn't tell us what happened at the very beginning, at the moment of the Big Bang itself, when our theories break down, when mathematics falters, when conceptual categories fail. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. At the Planck time, approximately 10·43 seconds after the beginning, the temperature was around 1032 degrees Kelvin. The four fundamental forces were unified. Space and time were so distorted by quantum fluctuations that the very concept of space-time may have been meaningless. Our current theories cannot describe this state. We can approach it mathematically, we can develop models that approximate it, but we cannot claim to truly understand it. And yet, from this incomprehensible initial state emerged everything we know: space, time, matter, energy, physical laws, galaxies, stars, planets, life, consciousness. The universe evolved from a state of extraordinary simplicity, a nearly homogeneous plasma of elementary particles, to the complex, differentiated, structured cosmos we observe. Entropy increased, yet complexity emerged. Disorder grew, yet order appeared. The arrow of time pointed toward greater dispersion of energy, yet along the way, it produced the extraordinary reduction of entropy that we call life, consciousness, intelligence, understanding. This cosmic evolution, from simplicity to complexity, from homogeneity to differentiation, from potential to actuality, is the greatest story in existence. It's the context in which all other stories unfold, the background against which all human dramas play out. And we're not merely passive observers of this story. We're participants, products of cosmic evolution who have developed the capacity to understand that evolution, to trace our own origins back to the earliest moments of the universe. Your body contains atoms forged in the nuclear furnaces of long-dead stars: carbon, oxygen, nitrogen, calcium, iron. Every breath you take includes molecules that have cycled through countless organisms over billions of years. The electrical signals in your brain, the thoughts forming in your mind, the consciousness that experiences these words, all emerge from processes that began in the earliest moments of cosmic history, from physical laws that were established in the first fractions of a second after the Big Bang. But this picture of cosmic evolution, compelling as it is, raises a profound question. Why? Why did the universe begin in a state of low entropy? Why do the physical laws have the particular form they do? Why do the fundamental constants have the specific values that allow for complexity, for life, for consciousness? The fine-tuning of the cosmos is a fact acknowledged by physicists across the ideological spectrum, from the most religious to the most secular. The values of fundamental constants, the strength of gravity, the mass of the electron, the strength of the nuclear forces, the cosmological constant, appear calibrated with extraordinary precision to allow for the emergence of complexity. Alter these values slightly, and the universe becomes sterile. Stars don't form, or they burn too briefly for life to evolve, or they don't produce the heavy elements necessary for biology, or matter itself becomes unstable. This fine-tuning demands explanation. Either it's an extraordinary coincidence, or it's the result of some selection effect, like the multiverse combined with the anthropic principle, or it's the product of purposeful design. None of these options is intellectually comfortable. All stretch our understanding to the breaking point. All remind us of how little we truly comprehend about the nature of existence. And here, we encounter a profound irony. The more we learn about the universe, the more we realize how little we know. The expansion of scientific knowledge doesn't diminish mystery. It deepens it. Each answer spawns new questions. Each discovery reveals new unknowns. The cosmic horizon recedes as we approach it, always tantalizingly beyond our reach. This isn't a failure of science. It's the nature of reality itself. Complex, layered, perhaps infinite in its depth. The universe isn't a puzzle to be solved, a code to be cracked, a machine to be dismantled and reassembled. It's a mystery to be explored, a wonder to be contemplated, a reality to be engaged with humility, curiosity, and awe. Consider the horizon problem in cosmology. Why is the cosmic microwave background radiation, the afterglow of the Big Bang, so uniform across the sky? Regions on opposite sides of the observable universe, separated by nearly 100 billion light-years, have nearly identical temperatures, differing by only about 1 part in 100,000. But these regions were never in causal contact. They were too far apart for light, or any form of information, to travel between them in the time available since the Big Bang. Inflation offers a potential solution. If the early universe underwent an exponential expansion, regions that were once in causal contact could have been stretched far apart, explaining the uniformity we observe. But inflation itself requires fine-tuning. Specific initial conditions, a particular scalar field with exactly the right properties, a carefully calibrated transition from inflationary expansion to standard Big Bang evolution. Or consider the flatness problem. Why is the geometry of the universe so precisely balanced between positive and negative curvature? Observations indicate that space is flat to within the limits of measurement precision, neither closed like a sphere nor open like a saddle, but balanced on the knife edge between these possibilities. This requires the initial density of the universe to have been exactly equal to the critical density, with a precision of 1 part in 10^60 or better. Inflation can address this problem too, by stretching any initial curvature until it became undetectable. But again, inflation itself requires fine-tuning. We've replaced one mystery with another, pushed the question back a step without providing a fundamental explanation. These aren't merely technical issues for specialists to debate. They're signs that our understanding of cosmic origins remains incomplete, that our most successful theories are, at best, approximations of a deeper reality we have yet to grasp. If the universe has no edge, then where does it begin? If space itself is expanding, What is it expanding into? If time had a beginning, what caused it to start? These questions might be malformed, based on conceptual frameworks that don't apply to the ultimate nature of reality. They might be like asking, what's north of the North Pole? Or, what does the color blue taste like? They might reflect the limitations of human cognition rather than the structure of the cosmos itself. And yet, we cannot help but ask them. We cannot suppress our curiosity, cannot contain our wonder, cannot restrain our drive to understand. It's what makes us human. It's what connects us to the cosmos, not merely as products of cosmic evolution, but as participants in the universe's quest to understand itself. In our questioning, in our wondering, in our ceaseless search for meaning and explanation, we fulfill our cosmic role. We become the universe contemplating its own existence, the cosmos achieving self-awareness through the temporary configuration of matter and energy that we call humanity. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. And we, the cool, complex structures that emerged from that primordial heat, are now trying to understand the furnace that forged us. We're the universe's way of knowing itself, of reflecting on its own nature, of pondering its own origins, and in that reflection, in that contemplation, in that pondering, we fulfill our cosmic purpose, not imposed from without, but emerging from within, from the intrinsic nature of reality itself. The canvas of the cosmos stretches before us, vast, mysterious, beckoning. We've learned to read some of its patterns, to decipher some of its codes, to glimpse some of its secrets. But the deeper we probe, the more we realize how much remains unknown, perhaps unknowable. And in that realization, that humbling yet thrilling recognition of the limits of human knowledge, we encounter not defeat, but invitation. An invitation to explore, to question, to wonder. An invitation to participate in the greatest adventure possible. The universe coming to know itself through the consciousness that emerged from its own evolutionary processes. So when we say the universe is 13.8 billion years old, we're not merely stating a scientific fact. We're telling a story of cosmic evolution, of emergence, of becoming. A story that begins in mystery, unfolds through complexity, and continues in the consciousness that contemplates it. A story in which we are not merely spectators, but participants, conscious nodes in the cosmic network, temporary configurations of matter and energy that have developed the capacity to wonder, to question, to understand. And that story is still being written, not just by the inexorable processes of cosmic evolution, but by our expanding understanding, our deepening comprehension, our evolving conception of reality itself. The universe is not just what it is. It's what we discover it to be, what we reveal it to be through our questioning, our investigation, our contemplation. Not because reality depends on our perception of it, but because our perception of reality is part of reality itself. The cosmos achieving self-awareness through the temporary configuration of matter and energy that we call humanity. The universe is 13.8 billion years old. This is one of the most secure facts in modern cosmology. And yet, what it means, what time is, what began, what caused it, what preceded it, remains a mystery. A mystery not to be solved, but to be lived. Not to be resolved, but to be explored. Not to be conquered, but to be entered, to be inhabited, to be embraced with humility, curiosity, and awe. Imagine reality as a film reel, where time is not flowing, but every moment already exists, past, present, and future, imprinted on frames that stand side by side in eternal, unchanging permanence. In this view, your birth, your death, and this moment of cosmic contemplation already exist, have always existed, will always exist, not as events that happen, but as locations in a four-dimensional structure that simply is. Your conscious experience is not the universe changing, but merely your awareness moving from one frame to the next, creating the illusion of time's passage. This is the block universe theory, the idea that time doesn't flow, but simply exists as a dimension, like space. It's not just philosophical speculation. It emerges naturally from Einstein's theories of relativity, which tell us that different observers can disagree about whether two events happen simultaneously or which came first. If there's no universal now that all observers can agree on, then perhaps all moments are equally real. The past still exists, the future already exists, and our experience of the present is merely a local, subjective phenomenon. But if time doesn't flow, if the future already exists in some sense, then what happens to causality? To free will? To the very notion of creation itself? If the universe isn't becoming but simply is, then nothing is truly created. Everything, including the apparent beginning of the universe, is just another location in the cosmic film reel, another frame in the eternal movie. And yet, we experience a universe of change, of becoming, of emergence. We witness stars being born and dying, galaxies forming and colliding, life evolving and diversifying. We experience our own thoughts arising, decisions being made, actions unfolding. How do we reconcile the block universe, suggested by relativity, supported by mathematics, with the flowing, changing, evolving cosmos we experience? This paradox isn't merely academic. It strikes at the heart of our investigation into cosmic origins. If time is an illusion, if the future is as real as the past, if nothing truly comes into being because everything simply is, then the question, what created everything, might itself be misconceived. Perhaps nothing was created because nothing ever began. Perhaps the universe, the entire cosmic film reel, with all its frames from beginning to end, simply exists timelessly, necessarily, eternally. But this raises a profound question. Why this particular film reel? Why these specific physical laws, these fundamental constants, this initial state? Why a universe that permits complexity, life, consciousness? If the cosmic film reel isn't created or selected from among possibilities, then its specific content, the particular story it tells, becomes an inexplicable brute fact, a mystery without resolution. Let's step deeper into the first of our cosmic paradoxes, singularities. In physics, a singularity is a point where a physical quantity becomes infinite, where mathematical description breaks down, where the laws of physics as we understand them cease to apply. Singularities appear in our theories in two primary contexts: at the heart of black holes and at the beginning of the universe. Consider a black hole, a region of space-time where gravity is so intense that nothing, not even light, can escape. At the center of a black hole, according to general relativity, lies a singularity, a point of infinite density, infinite curvature, infinite everything. Space and time cease to have meaning. Our mathematical models fail. Reality, as we understand it, breaks down. These cosmic drains aren't theoretical abstractions. We've observed their effects, captured their shadows, detected the gravitational waves from their collisions. They exist, massive, dark, enigmatic punctures in the fabric of reality. And at their hearts lie, what? Our equations can't tell us. Our theories fail. We reach the edge of knowledge, the boundary of understanding. Now, consider the Big Bang singularity, the infinitesimal point from which our entire universe apparently emerged. Like the singularity at the heart of a black hole, the Big Bang singularity represents a breakdown in our physical theories, a place where our mathematical models fail, where the concepts of space and time lose meaning. But there's a crucial difference. We can't observe the Big Bang singularity directly. We can't see past the cosmic horizon of the early universe, a veil of hot plasma that only became transparent about 380,000 years after the supposed beginning. Everything we know about the earliest moments of cosmic history comes from extrapolation, inference, theoretical modeling, and those models suggest something profound. The Big Bang singularity might not have been a singularity at all. Quantum mechanics, our theory of the very small, introduces fundamental uncertainties, minimal lengths, irreducible fuzziness. In the quantum realm, infinities are tamed, singularities smoothed out. When we apply quantum principles to the early universe, creating what physicists call quantum cosmology, the sharp point of the Big Bang singularity might dissolve into a quantum foam, a blurry region where space and time themselves become probabilistic, indeterminate, uncertain. Imagine the beginning of the universe not as a perfect point, but as a cloud of possibilities, a quantum superposition of potential. Universes, each with slightly different initial conditions, each with slightly different physical laws. Imagine cosmic history not as a single, determinate storyline, but as a branching tree of possibilities, a wave function of potential realities that collapsed, through the mysterious process of quantum measurement, into the particular cosmos we observe. This quantum perspective transforms our understanding of cosmic origins. The Big Bang wasn't a creation event in empty nothingness. It was a transition, from one mode of existence to another, from quantum indeterminacy to classical determinism, from a realm beyond space and time to the space-time manifold we inhabit. But this transformation doesn't solve the mystery of origins. It deepens it. What was the nature of this pre-geometric, pre-temporal quantum state? What determined the specific form of the quantum wave function from which our universe emerged? Why these probabilities rather than others? Why these potential universes rather than a different set? Here we encounter another paradox, the arrow of time. The fundamental laws of physics, from Newton's equations of motion to quantum field theory, are time-symmetric. They work equally well forward or backward. Drop a ball, and the physics describing its fall works perfectly if you run the film in reverse. Collide two particles, and the equations describing their interaction don't distinguish past from future. And yet, the universe we experience has a clear temporal asymmetry. Eggs break, but don't unbreak. Coffee cools, but doesn't spontaneously heat up. People age, but don't grow younger. Stars burn out, but don't reconstitute themselves. The universe expands, but doesn't contract. This one-way character of time, the ideal clear distinction between past and future, is called the arrow of time. And it's intimately connected to the concept of entropy, the measure of disorder, randomness, thermal equilibrium. The second law of thermodynamics tells us that in any closed system, entropy tends to increase over time. Order becomes disorder. Structure dissipates. Differences in temperature even out. The universe moves inexorably toward heat death. Eteder tiden, etu, state of maximum entropy, perfect equilibrium, total homogeneity. But this raises a profound question. If entropy always increases, if the universe is moving toward heat death, why isn't it there already? If the universe has existed for 13.8 billion years, shouldn't it have reached maximum entropy long ago? Why do we find ourselves in a universe of stars and planets, of temperature differences and energy gradients, of complex structures and living systems, a universe far from thermal equilibrium, far from maximum entropy? The answer seems to lie in the initial conditions. The early universe had extraordinarily low entropy. It was incredibly ordered, highly structured, far from equilibrium. The Big Bang wasn't a chaotic explosion. It was a remarkably uniform, incredibly precise initial state. And everything that's happened since, the formation of galaxies, stars, planets, life, has been the playing out of that initial order, the gradual increase of entropy from an extraordinarily low starting point. But this just pushes the question back. Why did the universe begin in such a low entropy state? Why was the Big Bang so orderly, so uniform, so structured? This is the past hypothesis, the idea that the initial conditions of the universe were extraordinary, special, highly unlikely. And it's not an explanation, it's a description, a restatement of the problem. Imagine shuffling a deck of cards and finding them arranged in perfect numerical order by suit. You wouldn't attribute this to random chance. You'd assume someone had ordered the deck. Similarly, the low-entropy initial state of the universe appears non-random, arranged, calibrated. But by what? By whom? For what purpose? Some physicists propose that the arrow of time isn't fundamental but emergent, a product of our perspective rather than a basic feature of reality. In this view, time's apparent direction is a result of how we relate to the universe, how we process information, how we form memories. Perhaps, from a God's eye view, there is no temporal asymmetry, no fundamental distinction between past and future. Perhaps the arrow of time is a subjective phenomenon, an artifact of consciousness, a result of the way we're embedded in the cosmic film reel rather than a property of the reel itself. Others suggest that the arrow of time is connected to the expansion of the universe. As the cosmos expands, it creates room for new configurations, new arrangements, new structures. Perhaps entropy increases because space itself is growing, providing more possibilities, more ways for matter and energy to be arranged. But these proposals don't fully resolve the mystery. They don't explain why the universe began in such a low entropy state. They don't tell us why the cosmic initial conditions were so special, so unlikely, so fine-tuned for the emergence of complexity. And here we encounter one of the most provocative ideas in modern cosmology: the multiverse. Imagine our universe as just one bubble in a vast, perhaps infinite cosmic foam. Each bubble is a separate universe, with its own physical laws, its own fundamental constants, its own initial conditions. Some bubbles collapse immediately after formation. Some expand for a time, then contract. Some reach equilibrium quickly, achieving heat death without ever developing complex structures. And some, perhaps a tiny fraction, have just the right properties to allow for the emergence of stars, planets, life, consciousness. This isn't science fiction. It's a serious theoretical proposal that emerges from several frameworks in modern physics: eternal inflation, string theory, quantum mechanics. Each offers a different mechanism, a different reason for believing in the existence of multiple universes. But all share a common implication. Our universe, with its particular physical laws and initial conditions, might be just one among many, perhaps infinitely many, alternative realities. Consider eternal inflation, the idea that the exponential expansion of space in the earliest moments of cosmic history never ends completely, but continues in some regions while stopping in others, creating pocket universes with different properties. In this scenario, new universes are constantly being born, bubbling out of the expanding quantum field like boiling water. Each bubble universe has its own Big Bang, its own subsequent evolution, its own physical laws determined by how the quantum fields settle into their ground states in that particular region. Or consider string theory, which suggests that the fundamental building blocks of reality aren't particles, but tiny, vibrating strings. The mathematics of string theory requires extra dimensions beyond the 3 spatial dimensions we experience, typically 7 additional dimensions curled up so tightly that we don't perceive them directly. But the way these extra dimensions are compactified determines the physical laws in our 4-dimensional space-time. And string theory allows for an enormous number of possible compactifications, around 10⁵ by some estimates, each corresponding to a different set of physical laws, different fundamental constants, different particle masses, different forces, or consider quantum mechanics itself, particularly the many worlds interpretation proposed by Hugh Everett. According to this view, every quantum measurement creates a branching of reality, with each possible outcome occurring in a different branch. The wave function never collapses. It merely appears to collapse from the perspective of observers who find themselves in specific branches. If this interpretation is correct, then reality isn't a single universe evolving through time, but a vast, ever-branching tree of possibilities, all equally real, all equally existent. These various multiverse theories differ in their details, their mechanisms, their empirical implications, but they all offer a potential explanation for the apparent fine-tuning of our cosmos. The fact that the fundamental constants of nature seem precisely calibrated to allow for complexity, for life, for consciousness. In a multiverse containing universes with all possible physical laws, all possible fundamental constants, all possible initial conditions. Of course, we find ourselves in one that permits our existence. It's not that the cosmos was designed for life, it's that life evolves, only in those regions of the multiverse where conditions permit it. This is the anthropic principle, the idea that our observations of the universe are necessarily conditioned by the requirements for our existence as observers. Imagine a vast cosmic garden containing every possible type of environment. Frozen, wastes, molten infernos, vacuum deserts, exotic realms with different chemical elements, different physical laws, different dimensional structures. In this garden, living observers will necessarily find themselves in the rare, special regions that support life. They'll observe a universe that appears fine-tuned for their existence, not because it was designed for them, but because they could only evolve in those particular regions in the first place. This anthropic reasoning isn't circular, it's selective. It doesn't explain why the multiverse exists, why it contains universes with all possible properties, why reality has the fundamental structure it does. But it does potentially explain why our observable universe has the specific properties it does, why the cosmological constant, the strength of the nuclear forces, the mass of the electron, and other fundamental parameters have the particular values we measure. These values aren't cosmically typical, they're observationally selected. We see them because those are the values that permit our existence as observers. The multiverse hypothesis is scientifically seductive. It offers a potential resolution to the fine-tuning problem without invoking supernatural design. It brings the extraordinary nature of our cosmos, its particular physical laws, its specific fundamental constants, its special initial conditions, into the realm of scientific explanation rather than theological speculation. But this explanatory power comes at a cost. The multiverse hypothesis posits entities, other universes, that are, by definition, unobservable from within our universe. It makes claims about reality that cannot, even in principle, be directly empirically verified or falsified using the methods of science as traditionally practiced. This tension between explanatory power and empirical testability raises profound questions about the nature and limits of scientific knowledge. Is a theory scientific if it posits entities that cannot, even in principle, be directly observed? Is an explanation satisfying if it invokes an infinite proliferation of unobservable causes? Is the multiverse hypothesis a scientific theory, a metaphysical framework, or something that blurs the boundaries between these categories? These questions aren't merely academic. They cut to the heart of our cosmic investigation. If the multiverse exists, then the question, what created everything, transforms into what created the multiverse. The explanatory regress doesn't end. It merely shifts to a larger stage, a more encompassing framework, a deeper level of reality. And, even within the multiverse framework, profound questions remain. What determines the possibility space of the multiverse? The range of physical laws, fundamental constants, initial conditions that can be realized across different universes. Why these possibilities rather than others? Why a multiverse that contains universes capable of supporting life, consciousness, intelligence? Why a fundamental reality that permits complexity at all? The multiverse doesn't eliminate the mystery of cosmic origins. It recursively embeds it within a larger mystery. It doesn't remove the question of design. It pushes it back a level, from the specific properties of our universe to the general structure of the multiverse itself. It doesn't solve the problem of fine-tuning. It transfers it from the calibration of physical constants to the calibration of the multiverse's possibility space. Let's step deeper into the cosmos, into the realm of black holes, cosmic objects so massive, so dense, that not even light can escape their gravitational pull. These cosmic drains aren't merely destructive, they might be creative as well. Some physicists, including Lee Smolin, have proposed the theory of cosmological natural selection, the idea that black holes might give birth to new universes. Imagine the singularity at the heart of a black hole, not as a dead end, not as a point of infinite density where physics breaks down, but as a cosmic rebirth, a new Big Bang, creating a new universe with slightly different physical laws, slightly different fundamental constants. In this scenario, universes that produce more black holes generate more offspring universes. Cosmic evolution favors universes whose physical laws maximize black hole production. And here's where it gets intriguing. The same physical laws that optimize black hole production also happen to create conditions favorable for life. Stars must live long enough to produce heavy elements. Gravity must be strong enough to create stellar collapse, but not so strong that all matter immediately forms black holes. Nuclear forces must be calibrated to produce the elements essential for complex chemistry. The requirements for prolific black hole production overlap significantly with the requirements for the emergence of life. This theory, speculative, controversial, not widely accepted, offers a potential explanation for cosmic fine-tuning based on principles analogous to Darwinian evolution. Universes whose physical laws produce more black holes leave more descendants in the cosmic population. Over many generations, the multiverse evolves toward configurations that maximize black hole production, which, coincidentally or not, also create conditions conducive to life. But this theory, like many attempts to explain cosmic origins, raises as many questions as it answers. Where did the first universe come from? What determined its physical laws? Why do black hole singularities create new universes rather than simply crushing matter to infinite density? How is information about physical laws transmitted from parent universe to offspring universe? And deeper still, why does the multiverse have the particular evolutionary dynamics it does? Why these selection pressures rather than others? Why a cosmic process that happens to favor conditions conducive to life? We seem caught in an infinite regress, each explanation invoking a deeper framework that itself requires explanation. Let's turn now to one of the most counterintuitive aspects of quantum mechanics: quantum entanglement. When two particles interact, they can become entangled, their properties correlated in ways that seem to transcend space and time. Measure the spin of one entangled particle, and you instantly know the spin of its partner, even if they're separated by billions of light years. This correlation isn't due to some hidden communication between the particles. It's a fundamental feature of quantum reality, a manifestation of what Einstein called spooky action at a distance. Quantum entanglement has been experimentally verified countless times. It's not just theoretical, it's real, and it suggests a universe far stranger, far more interconnected than our intuitions prepared us to understand. A cosmos in which separation might be an illusion, in which distant objects might be non-locally connected, in which the whole might be more fundamental than its parts. Some physicists, including Juan Maldacena, have proposed that space-time itself might emerge from quantum entanglement, that the fabric of reality, the stage upon which cosmic drama unfolds, might be woven from entanglement relationships between quantum entities. In this view, space isn't fundamental, it's emergent, a manifestation of a deeper quantum reality in which notions of here and there dissolve into patterns of correlation, connection, entanglement. This perspective transforms our understanding of cosmic origins. The Big Bang wasn't the beginning of everything. It was the emergence of space-time from a pre-spatial, pre-temporal quantum reality defined by patterns of entanglement. The question isn't what created everything, but how did the space-time manifold we inhabit crystallize from the quantum substrate that underlies it? But this just pushes the mystery back another level. If space-time emerges from quantum entanglement, from what do the quantum entities themselves emerge? If reality is fundamentally quantum, what determines the specific form of the quantum fields, the particular patterns of entanglement, the exact wave function of the universe? We seem caught in a conceptual loop, each explanation invoking a deeper framework that itself requires explanation. It's not that our theories are wrong, it's that they're incomplete, approximations of a deeper reality we have yet to fully grasp. Imagine reality as an onion, with each layer of explanation peeling back to reveal another layer beneath. Classical physics gives way to quantum mechanics, which gives way to quantum field theory, which gives way to string theory or loop quantum gravity or some other framework yet to be discovered. Each layer provides a more fundamental description, a deeper understanding, a more comprehensive framework. But does this process end? Is there a final layer, a rock-bottom reality, a theory of everything that explains everything else without itself requiring explanation? Some physicists and philosophers believe there must be such a final theory, a complete description of reality that is logically self-contained, mathematically consistent, empirically adequate. This theory would explain the origin of the universe, the nature of space and time, the properties of matter and energy, the emergence of complexity and consciousness, all from first principles, without appeals to anything outside itself. Others suspect that the process of scientific explanation might be infinite, that there is no final theory, no bottom layer of the onion, just an endless series of better and better approximations, each revealing new puzzles, new questions, new mysteries. In this view, the cosmos isn't a problem to be solved, but a reality to be engaged, a mystery to be explored without end. Both perspectives have their appeal, their strengths, their weaknesses. A final theory would satisfy our yearning for completion, for closure, for ultimate understanding. But an infinite regress of explanation mirrors the open-ended, evolving, unbounded character of scientific inquiry itself. The endless process of questioning, investigating, revising that has characterized human engagement with the cosmos for millennia. Let's turn now to one of the most bizarre implications of quantum mechanics: the quantum nature of vacuum. In classical physics, vacuum is nothing, empty space, void, the absence of everything. But in quantum physics, vacuum is something, a seething ocean of virtual particles, popping in and out of existence, borrowing energy from the future and repaying it before the cosmic accountant notices the discrepancy. This isn't a metaphor. It's a description of reality supported by experimental evidence. The Casimir effect, the Lamb shift, vacuum polarization all confirm the active, dynamic nature of quantum vacuum. This quantum perspective transforms our understanding of nothing. The vacuum isn't empty. It's full of fields, of potential, of virtual particles, of energy. Even in the absence of matter, even in the darkest regions of intergalactic space, reality teems with quantum activity, with possibility, with the seeds of manifestation. And this has profound implications for our investigation of cosmic origins. The universe didn't emerge from true nothingness, from absolute non-being, from void, from complete absence. It emerged from quantum vacuum, from a state of immense potential, immense energy, immense possibility. The Big Bang wasn't the creation of something from nothing. It was the transformation of one kind of something, quantum vacuum, into another kind of something, the expanding space-time manifold filled with matter and radiation. But this just pushes the question back. Where did the quantum vacuum come from? Why these quantum fields rather than others? Why these physical laws rather than different ones? We seem caught in an explanatory regress, each answer spawning new questions in an infinite series. Perhaps the problem lies in the question itself. Perhaps, where did X come from? Assumes a temporal framework, a causal sequence, a chain of events that might not apply to the fundamental nature of reality. Perhaps the universe, or the quantum vacuum from which it emerged, or the deeper reality underlying that vacuum, doesn't come from anywhere because it doesn't begin. Perhaps it simply is, timelessly, necessarily, without creation or destruction. This idea that ultimate reality is necessary, that it couldn't not exist, that its non-existence is logically impossible, has ancient roots. Philosophers from Parmenides to Spinoza have argued that true being cannot not be, that the fundamental nature of reality is necessary existence. Some modern physicists, including Max Tegmark, have proposed similar ideas, that the universe is a mathematical structure, and mathematical structures exist necessarily, inevitably, without cause or creator. In this view, the question isn't what created everything, but why is everything the way it is rather than some other way? Not why is there something rather than nothing, but why these particular somethings rather than others? But even this reformulated question raises profound puzzles. Why these mathematical structures rather than others? Why these physical laws rather than different ones? Why a reality that permits complexity, life, consciousness? The mystery of cosmic origins transforms but doesn't dissolve. It shifts from the problem of creation, ex nihilo, to the problem of selection, of determination, of cosmic preference for one possibility over others. Let's step deeper still into the realm of information theory and its implications for our understanding of reality. In recent decades, physicists including John Wheeler and Seth Lloyd have proposed that information might be more fundamental than matter, energy, space, or time. that the cosmos is at its core a computational system, a processing of information according to rules. In Wheeler's memorable phrase, "it from bit," physical reality emerges from information, not the other way around. This perspective transforms our understanding of cosmic origins. The universe isn't made of stuff that was created at some point in the past. It's made of information that is constantly being processed, computed, actualized according to algorithmic rules. The Big Bang wasn't the beginning of everything. It was a phased transition in cosmic computation, a shift from one information processing regime to another. But this information-theoretic view raises profound questions. What determines the rules of cosmic computation? Why these algorithms rather than others? Why a computational cosmos that produces consciousness, that permits self-awareness, that allows for the emergence of entities capable of investigating their own origins? And deeper still, if information is fundamental, what is the medium of this? Information? If reality is computation, what is the computer? If the cosmos is algorithmic, what executes the algorithm? We seem caught in an infinite regress, each explanation requiring a deeper framework that itself demands explanation. Perhaps the solution lies in a radical reconceptualization of time itself, in the timeless or block universe view suggested. By relativity, time doesn't flow. Past, present, and future all exist with equal reality in a four-dimensional structure that simply is. Your birth, your death, and this moment of cosmic contemplation all exist timelessly, eternally, unchangingly, not as events that happen, but as locations in a space-time manifold that simply is. This perspective transforms our understanding of creation. Nothing comes into being. Nothing ceases to be. Everything, past, present, future, simply exists in its proper location within the space-time manifold. The universe isn't created at the Big Bang. The Big Bang is simply a particular location within the eternal, unchanging block universe. But this just pushes the question back. Why this particular block universe? Why these specific contents rather than others? Why a space-time manifold that contains complexity, life, consciousness? The mystery doesn't dissolve. It transforms, shifts focus, changes form. Perhaps the problem lies in our conceptual framework itself. Perhaps our categories of something and nothing, of existence and non-existence, of creation and eternal being, are themselves inadequate, approximations of a reality that transcends these binary oppositions, these either-or distinctions, these products of human cognitive evolution. Consider quantum superposition. The fact that quantum systems can exist in multiple states simultaneously, that a particle can be both here and there, that Schrödinger's cat can be both alive and dead until observed. This isn't a metaphor. It's a description of reality supported by experimental evidence. Quantum systems don't merely occupy uncertain positions that become determinate upon measurement. They exist in genuine superpositions, in multiple states at once, in possibilities that aren't actualized until observed. What if reality itself, not just quantum particles, but the cosmos as a whole, including its origin, its evolution, its fundamental nature, exists in a kind of superposition, a state that transcends our binary categories of being and non-being, something and nothing, creation and eternal existence? This isn't mysticism or obscurantism. It's a recognition that our conceptual categories, evolved for navigating the middle-scale reality of everyday experience, might be inadequate for comprehending the fundamental nature of the cosmos. Just as Newtonian physics breaks down at quantum scales and relativistic velocities, our intuitive categories of being and becoming, something and nothing, creation and existence, might break down when applied to the ultimate nature of reality. Consider the paradox of quantum measurement, the fact that observation appears to collapse quantum superpositions into definite states, that the act of measurement seems to actualize one possibility from among many. This collapse of the wave function remains one of the most puzzling aspects of quantum mechanics, a process that our mathematical formalism describes but doesn't explain. Some interpretations of quantum mechanics, including the Copenhagen interpretation, suggest that observation plays a crucial role in the manifestation of definite reality from quantum potential. Others, like the many worlds interpretation, propose that all possibilities are realized in parallel universes, with observation merely determining which branch of reality the observer experiences. Still others, like pilot wave theory, suggest that quantum systems have definite properties all along, guided by a wave function that evolves according to the Schrödinger equation. These interpretations differ radically in their ontological implications, in what they tell us about the fundamental nature of reality, but all agree on the empirical predictions of quantum mechanics. All accommodate the same experimental results. All provide frameworks for calculating the probabilities of various measurement outcomes. This interpretive plurality, the fact that multiple, radically different ontological frameworks can accommodate the same empirical observations, suggests a profound limitation in our ability to determine the ultimate nature of reality through observation alone. The cosmos might be like Kant's thing in itself, a reality beyond our direct access, approachable only through conceptual frameworks, models, interpretations that filter, organize, and inevitably distort our experience. This doesn't mean that science is subjective or that reality is a social construction. It means that our scientific theories are models, representations of reality, not reality itself. And like all models, they're approximations, simplifications, filters that capture some aspects of reality while neglecting others. They're maps, not territories, useful for navigation, invaluable for prediction, essential for understanding, but not identical with the reality they represent. And this has profound implications for our investigation of cosmic origins. The Big Bang Theory, the inflationary model, quantum cosmology, string theory, loop quantum gravity. These aren't the reality of cosmic beginnings. They're models, representations, approximations of a reality that might transcend all of them. They're maps, not territories, useful for navigation, valuable for prediction, essential for understanding, but not identical with the reality they represent. This doesn't mean that these theories are wrong or that science can't progress in its understanding of cosmic origins. It means that scientific progress involves not just the refinement of existing models, but the development of new conceptual frameworks, new categories, new ways of thinking that might better capture aspects of reality our current models neglect or distort. Consider the history of physics. Newtonian mechanics wasn't proved wrong by Einstein's theories of relativity. It was revealed to be a special case, an approximation valid under certain conditions, a model with a limited domain of applicability. Similarly, classical physics wasn't refuted by quantum mechanics. It was shown to be a special case, an approximation, valid for large systems, a model that breaks down at microscopic scales. Perhaps our current theories of cosmic origins, the Big Bang model, inflation, quantum cosmology, will suffer a similar fate. Not proved wrong, but revealed to be special. Cases, approximations valid under certain conditions, models with limited domains of applicability. Perhaps they'll be subsumed within a more comprehensive framework, a deeper theory, a more fundamental understanding that recontextualizes rather than refutes our current models. This vision of scientific progress, not as the steady accumulation of facts within a fixed conceptual framework, But, as the punctuated evolution of the conceptual frameworks themselves suggests that our understanding of cosmic origins might evolve in ways we cannot currently imagine. Through conceptual revolutions, we cannot currently anticipate using categories and frameworks we have not yet developed. And this open-endedness, this conceptual humility, this recognition of the provisional nature of even our most successful theories might be the proper stance toward the mystery of cosmic origins. Not a problem to be solved once and for all, but a reality to be approached asymptotically, through an endless series of better and better approximations, each revealing new aspects of the inexhaustible mystery at the heart of existence. Imagine the cosmos not as a machine to be dismantled and reassembled, not as a puzzle to be solved, not as a code to be cracked, but as a mystery to be entered, a reality to be engaged, a truth to be approached through an endless process of questioning, investigating, modeling, and revising. In this view, the question isn't, what is the answer to the mystery of cosmic origins? But how can we develop better questions, better conceptual frameworks, better models for engaging with this mystery? This doesn't mean abandoning the scientific quest for understanding. It means recognizing the limitations inherent in that quest, the provisional nature of scientific knowledge, the constructed character of scientific theories, the inevitable approximations involved in any model of reality. It means approaching the cosmos with both intellectual rigor and conceptual humility, with both analytical precision and openness to mystery, with both critical thinking and a willingness to revise our most fundamental categories if reality demands it. Consider the limitations of human cognition itself. Our brains evolved for navigating the middle-scale reality of everyday experience, for tracking game, avoiding predators, finding mates, cooperating with other humans. They didn't evolve for comprehending quantum mechanics, general relativity, higher dimensional geometry, or the origins of the universe. Our intuitive categories, our conceptual frameworks, our cognitive capacities themselves might be inadequate for fully grasping the fundamental nature of reality. This doesn't mean that human understanding is impossible or that science is futile. It means that our understanding is always mediated by our cognitive architecture, filtered through our conceptual categories, limited by our evolved mental capacities. We approach the cosmos not directly, not as it is in itself, but through the lenses of perception, cognition, conceptualization, theorization that define human experience. And this has profound implications for our investigation of cosmic origins. The quest isn't to discover the absolute, final, complete truth about how everything began. It's to develop better models, better approximations, better conceptual frameworks for engaging with a reality that might always exceed our full comprehension. This approach, combining intellectual rigor with conceptual humility, analytical precision with openness to mystery, characterizes the best of scientific inquiry. It's not a retreat from the scientific quest for understanding. It's an acknowledgement of the nature and limits of that quest, a recognition that our models are always approximations, our theories always provisional, our understanding always incomplete. And perhaps this incompleteness, this provisionality, this endless process of questioning, investigating, modeling, and revising isn't a bug but a feature. Not a failure of scientific understanding, but a reflection of the inexhaustible nature of reality itself. Perhaps the cosmos isn't a problem to be solved, but a mystery to be engaged, a reality to be approached through an endless series of better and better approximations, each revealing new aspects of the truth without exhausting it. You've been sitting here, absorbing these cosmic truths with the detached curiosity of an observer. But now, for just a moment, I want you to truly feel them. Not as concepts, not as theories, but as reality, your reality. If time is an illusion, then everything you've ever done, every choice you've ever made, every moment you've ever loved, might have already happened infinite times before. The first kiss, the worst betrayal, the birth of your child, the death of someone irreplaceable. All existing simultaneously in the cosmic film reel, all playing out over and over, in exact replica across the cold expanse of the block universe. You're not moving through time. Time is moving through you. And the you reading these words right now is just one frozen cross-section of your eternal existence, trapped in amber. Take a breath. Feel the air entering your lungs. This simple act connects you to the vast, incomprehensible cosmos we've been exploring. That oxygen was forged in the nuclear furnace of a star that exploded billions of years ago. The iron in your blood was created in the cataclysmic collision of neutron stars that died before our solar system was born. Your body, every atom, every subatomic particle, was once part of something else. A star, a cloud of interstellar gas, perhaps another living being. Your physical form is borrowed, a temporary configuration of matter that will eventually disassemble and become something else entirely. You are not separate from this cosmic drama. You are it. Look at your hands, the skin, the bones, the intricate network of blood vessels. This architecture wasn't designed for cosmic contemplation. Your brain, the organ with which you're processing these words, evolved to help your ancestors find food, avoid predators, secure mates, raise offspring. It wasn't built to comprehend quantum superposition or 11-dimensional string theory, or the beginning of time itself. The cognitive tools you're using to understand the universe are almost comically inadequate for the task, like trying to measure the temperature of a star with a mercury thermometer. And yet, here you are, contemplating your own origins, questioning the nature of reality, staring into the cosmic abyss and demanding answers. What does it mean that you exist at all? That consciousness somehow emerged from cosmic dust? That the universe evolved a way to be aware of itself? Consider the statistical impossibility of your existence. For you to be born, every one of your ancestors, stretching back to the first self-replicating molecules, had to survive long enough to reproduce. Every sperm and egg that united to form each link in your genetic chain had to find each other, among countless alternatives. Had any single one of these countless contingent events unfolded differently, you, the specific, unique consciousness experiencing these words, would never have existed. You are a miracle, a statistical anomaly so profound that the term improbable doesn't begin to capture it. Now zoom out, way out, beyond your body, beyond this planet, beyond the solar system, beyond the galaxy. The observable universe contains approximately 2 trillion galaxies. Each galaxy contains, on average, 100 billion stars. Many of these stars host planetary systems. The sheer scale renders your existence, your problems, your achievements, your entire civilization vanishingly small. If the cosmos were an ocean, humanity wouldn't be a drop. We'd be a few molecules of water. And yet, strangely, we may be the only beings in this vast expanse capable of contemplating it. The only consciousness that has evolved to ask why. The only collection of atoms that looks up at the night sky and wonders what it all means. What if we are utterly, completely alone? What if, in this incomprehensible vastness, consciousness emerged just once, here, on this pale blue dot? What if we are the universe's only witness, its only mirror, the sole instance where the cosmos evolved the capacity to reflect upon itself? Or what if the opposite is true? What if consciousness is abundant, ubiquitous, fundamental to reality itself? What if the universe is alive, and we are just its fleeting thoughts? What if awareness isn't an accidental byproduct of neural complexity, but a basic feature of existence, as fundamental as mass or charge? Both possibilities are equally terrifying, equally awe-inspiring. If we are alone, then we bear an unimaginable responsibility to survive, to understand, to witness the universe that brought us forth. We are the cosmos' only self-reflection, its only means of self-understanding. If humanity disappears, the universe loses something irreplaceable: its capacity for self-awareness, for meaning-making, for contemplation of its own existence. But if consciousness is ubiquitous, if awareness permeates reality at levels we cannot comprehend, then we are never truly alone, but perhaps also never truly unique, never truly separate, never truly individual in the way we imagine ourselves to be. We might be temporary configurations of a universal consciousness, brief eddies in the cosmic stream of awareness, fleeting patterns in the fundamental field of being. Either way, the implications shatter our comfortable assumptions about who and what we are. Now consider time again, not as an abstraction, but as the medium of your existence. Every moment of your past still exists. The child you were, the adolescent, the young adult. They're all still there, eternally preserved in the amber of space-time. The future you, the older you, perhaps even the dying you, already exists, has always existed, will always exist. Your entire life, from first breath to last, is a complete eternal structure in the four-dimensional block universe. If this is true, and relativity suggests it is, then nothing is ever truly lost. The key: moments you cherish, the people you've loved, the experiences that defined you, they're not gone. They're just elsewhere in the cosmic film reel, as real, as present, as existent as this moment right now. But it also means that nothing is ever truly created. Nothing comes into being. Nothing is accomplished. Nothing changes. Everything, past, present, future, simply is, fixed and eternal in the four-dimensional structure of space-time. What does that mean for free will, for choice, for moral responsibility? If the future already exists, if your decisions are already made, if your life is a complete space-time structure that simply exists rather than unfolds, are you truly free? Do your choices matter if they're already determined, already actualized, already fixed in the eternal block universe? And what of death? If time doesn't flow, if the future is as real as the past, if your entire life exists as a complete, eternal structure in four-dimensional space-time, then perhaps death isn't the end of existence, but merely a boundary, a temporal limit analogous to the spatial boundaries of your body. Your life doesn't cease to exist when it ends, just as a yardstick doesn't cease to exist beyond its 36th inch. But this cold comfort comes at a terrible price. If death isn't the end of your existence in the block universe, then neither is birth its beginning. You don't come into being, you don't cease to be. You simply are, a complete, eternal, unchanging structure in space-time. Does this expand your existence or diminish it? Does it make death less terrifying or life less meaningful? Now consider the multiverse, not as an abstract theory, but as an existential reality. If the multiverse exists, If reality comprises countless universes with different physical laws, different histories, different possibilities, then everything that can happen does happen, somewhere in the vast landscape of possible worlds. In some universe, you made a different choice at every crossroads. In some universe, you pursued the career you abandoned, married the person you let go, lived in the city you only visited. In some universe, you're already dead. In others, you were never born. In some, your entire civilization took a radically different path. In others, life never evolved at all. If all possible worlds exist, if the wave function never collapses but merely branches into parallel realities, then nothing is unique. Nothing is singular. Nothing happens just once. Every possibility is actualized somewhere in the cosmic landscape. What does this mean for the significance of your choices, your experiences, your existence? If everything that can happen does happen somewhere in the multiverse, does anything truly matter? If every possible version of you exists across the landscape of parallel worlds, which one is really you? All of them? None of them? The one you happen to be experiencing now? And what of meaning, of purpose, of significance? If reality is an infinite landscape of possibility, where everything that can happen does happen, where nothing is unique, where nothing happens just once, can anything truly matter? Can any choice be morally significant if all possible choices are actualized somewhere? Can any achievement be meaningful if all possible outcomes exist? Or does the infinity of possibilities not diminish significance but expand it? Perhaps meaning isn't found in uniqueness but in participation, not in singularity but in relationship, not in what happens only once, but in what happens here, now, in this branch of the cosmic tree, in this particular actualization of possibility that you are experiencing. Now confront the paradox of your own consciousness. How does the subjective experience of being you, the taste of coffee, the pain of heartbreak, the wonder of a sunset, emerge from the electrical and chemical processes? In your brain? How does awareness arise from arrangement of atoms? How does subjectivity emerge from objectivity, experience from mechanism, first-person perspective from third-person processes? This is the hard problem of consciousness, the question of how and why physical processes in the brain give rise to subjective experience. And it's not merely a scientific puzzle, it's an existential conundrum that cuts to the heart of what it means to be human, to be aware, to be you. If consciousness is merely a product of neural complexity, a byproduct of information processing in the brain, then your subjective experience, the very essence of what it means to be you, is in some sense an illusion, a kind of user interface evolved to help your genes survive and replicate. The rich, vibrant, intensely real experience of being alive would be, in this view, merely a useful fiction generated by your brain, a simulation of reality rather than direct access to it. But if consciousness is more fundamental, if awareness is somehow intrinsic to reality rather than emergent from neural complexity, then the cosmos itself might be more like mind than matter at its deepest levels. The hard boundary between subject and object, between awareness and the world, between mind and matter, might be an artifact of our limited perspective rather than an intrinsic feature of reality. Either possibility is vertigo-inducing. Either we are essentially elaborate biological robots experiencing the useful illusion of selfhood, or we are manifestations of a cosmos that is more like mind than matter at its foundations. Either consciousness is a complex emergent phenomenon with no cosmic significance, or it is woven into the fabric of reality itself. What does it mean to be human in light of these possibilities? What does it mean to be you? Now confront the possibility that nothing created everything because nothing, true nothingness, absolute non-being, never existed and never could exist. What if existence itself is necessary, inevitable, inescapable? What if the question, why is there something rather than nothing, is based on a fundamental misconception? The idea that nothingness is the default state, the natural condition, the starting point from which existence must be explained. What if being is primary, fundamental, necessary, and non-being is what would require explanation, if it were possible at all? What if existence itself couldn't not be, couldn't fail to manifest in some form, couldn't help but actualize its potential? This possibility is as philosophically challenging as it is poetically resonant. It suggests that existence itself isn't a brute fact requiring explanation, isn't a cosmic accident, isn't a mysterious emergence from nothingness, but is instead the fundamental, necessary, inescapable nature of reality itself. But this just pushes the question back. Why this particular existence? Why these physical laws, these fundamental constants, this cosmic history, this specific manifestation of being rather than some other? Why a universe that permits complexity, life, consciousness, rather than a sterile cosmos of undifferentiated matter or pure radiation? The fine-tuning problem doesn't disappear, it transforms. The question isn't, why is there something rather than nothing? But why this something rather than some other something? Not, why does existence exist? But, why does existence take this specific form? And perhaps there is no answer, no explanation, no reason. Perhaps the specific form of existence is a brute fact, an uncaused reality, a feature of being that simply is the way it is, without deeper justification or purpose. Or perhaps there is purpose, meaning, intention woven into the fabric of reality itself, not imposed from without by a transcendent creator, but emerging from within as an intrinsic feature of existence, as fundamental as space or time or energy. Either possibility is both intellectually challenging and emotionally unsettling. Either reality is, at its foundation, arbitrary and purposeless, a cosmic accident with no deeper meaning, no transcendent significance, no inherent value. Or reality contains within itself the seeds of purpose, meaning, value, not as human projections onto a neutral cosmos, but as intrinsic features of existence itself. What does it mean to be human in light of these possibilities? What does it mean to be alive, aware, capable of contemplating your own origins in a cosmos that might be fundamentally purposeless or fundamentally purposeful in ways that transcend human understanding? Now, confront the existential implications of entropy, the universal tendency toward disorder, equilibrium, homogeneity. The second law of thermodynamics tells us that in any closed system, entropy always increases. Order becomes disorder. Structure dissipates. Differences in temperature even out. The universe moves inexorably toward heat death, a state of maximum entropy, perfect equilibrium, total homogeneity. This applies not just to thermodynamic systems, but to all organized structures, including living beings, civilizations, planets, stars, galaxies. Everything that exists as a structured, ordered, complex entity will eventually disintegrate, dissolve, return to equilibrium with its environment. Not just you, not just your civilization, not just your planet, but everything that exists will eventually succumb to entropy's inexorable pull. The universe began in a state of extraordinarily low entropy, highly ordered, highly structured, far from equilibrium. And everything that's happened since, the formation of galaxies, stars, planets, the emergence of life, the evolution of consciousness, the development of civilization, has been the playing out of that initial order, the gradual increase of entropy from an extraordinarily low starting point. But the process isn't reversible. The arrow of time points in one direction, toward increasing entropy, toward dissolution, toward equilibrium. Eventually, in 100 years perhaps, the universe will reach a state of maximum entropy. All stars will burn out. All black holes will evaporate. All matter will be dispersed. All energy will be uniformly distributed. All structure, all complexity, all life will be gone. The cosmos will become a vast, dark, cold, homogeneous soup of elementary particles, a state from which no structure can ever again emerge. No complexity can ever again evolve. No life can ever again develop. This is the heat death of the universe, the ultimate fate of everything that exists according to our best understanding of physics. Not with a bang, but with a whimper. Not with apocalyptic destruction, but with endless, unchanging homogeneity. Not with divine judgment, but with thermodynamic inevitability. What does this mean for the significance of human existence, human achievement, human civilization? If everything we create, everything we discover, everything we build will eventually be erased without trace, without record, without remnant, does anything we do truly matter? If the universe itself will eventually become a lifeless, structureless soup of elementary particles, incapable of supporting awareness or memory or meaning, what significance can any action, any creation, any discovery truly have? The heat death of the universe confronts us with the ultimate cosmic futility, the eventual erasure of everything that exists, everything that matters, everything that means anything to anyone. Not just human civilization, not just life on Earth, not just our solar system or our galaxy, but everything, everywhere, for all time. A cosmic reset to uniform equilibrium from which no structure, no complexity, no life, no meaning can ever again emerge. In the face of this cosmic finality, this thermodynamic inevitability, this eventual erasure of everything that exists, what meaning can human life, human civilization, human achievement possibly have? Perhaps meaning isn't found in permanence, but in temporarily. Not in eternal significance, but in present value. Not in lasting consequence, but in current relationship. Perhaps what matters isn't what lasts forever, since nothing will, but what exists now, what happens here, what unfolds in this brief window of cosmic time during which complexity, life, consciousness are possible. Or perhaps the heat death of the universe isn't the final word. Perhaps there are cosmic cycles, quantum, resurrections, dimensional transitions that our current physics doesn't capture, doesn't model, doesn't predict. Perhaps the end of our universe is the beginning of another. The heat death of this cosmos, the birth pangs of the next, the maximum entropy of one reality, the low entropy initial conditions of another. Either way, the eventual heat death of the universe, the thermodynamic finality of everything that exists, forces us to confront the cosmic impermanence of all structure, all complexity, all life, all meaning. Nothing lasts forever. Nothing endures eternally. Nothing escapes entropy's inexorable pull toward equilibrium, homogeneity, featurelessness. What does it mean to be human in light of this cosmic impermanence? What does it mean to create, to discover, to build, to love in a universe that will eventually erase all trace, all record, all memory of everything that ever existed? Now confront the cosmic insignificance of human existence, not just individually, but collectively, as a species, as a planetary civilization, as the sum total of all human achievement and experience. The observable universe is approximately 93 billion light-years in diameter. It contains approximately 2 trillion galaxies, each with approximately 100 billion stars. Many of these stars host planetary systems. The sheer scale renders Earth, the only home humanity has ever known, vanishingly small, cosmically insignificant. If the entire history of the universe were compressed into a single cosmic year, with the Big Bang on January 1st and the present moment at midnight on December 31st, then the entire history of human civilization would occupy the last few seconds of the last minute of the last day. Modern humans emerged around 11:59 to 56 p.m. The Industrial Revolution began at 11:59 to 59. Your entire life occupies a fraction of the last second of the cosmic year. Not only is human existence brief on cosmic timescales, it's confined to an infinitesimal region of cosmic space. Even if humanity eventually spreads throughout the Milky Way galaxy, an extraordinarily optimistic scenario given the challenges of interstellar travel, we would occupy just one galaxy among 2 trillion in the observable universe. Our cosmic footprint would be invisibly small, vanishingly insignificant. What does this cosmic insignificance mean for human purpose, human meaning, human significance? If we are so small, so brief, so limited in our cosmic scope, does anything we do truly matter on the scale of the universe? Does human civilization have any cosmic significance whatsoever? Or are we merely a temporary, localized anomaly in the vast cosmic process? A brief flicker of complexity in a universe trending toward heat death, a momentary deviation from equilibrium in the long arc of increasing entropy. The scale of the cosmos, its vast spatial extent, its immense temporal duration, its overwhelming complexity, isn't just intellectually challenging, it's emotionally devastating. It confronts us with our own cosmic insignificance, not just as individuals, but as a species, as a civilization, as a planetary biosphere. We are so small, so brief, so limited, so insignificant on the scale of the cosmos. And yet, and here's the existential paradox, we are also the cosmos knowing itself. We are matter aware of its own existence. We are the universe evolved to the point of self-reflection, self-understanding, self-contemplation. We are the means by which the cosmos has developed the capacity to investigate its own origins, to trace its own evolution, to contemplate its own nature. In our cosmic insignificance, we find a strange kind of cosmic significance. We are vanishingly small, and yet we may be the only beings in the observable universe capable of asking why, of seeking meaning, of contemplating origins, of investigating the nature of reality itself. We are cosmic dust, and yet we are cosmic dust that knows it's cosmic dust, that traces its own origins to stellar furnaces, that contemplates its own existence. What if we are utterly, completely alone? What if, in the vast cosmic expanse, consciousness emerged just once, here, on this pale blue dot? What if we are the universe's only witness, its only mirror, the sole instance where the cosmos evolved the capacity to reflect upon itself? If so, then despite our cosmic insignificance in space and time, we would possess a strange kind of cosmic significance as the universe's only self-reflection, its only means of self-understanding, its only capacity for contemplating its own existence. If humanity disappears, the universe loses something irreplaceable. its capacity for self-awareness, for meaning-making, for contemplation of its own nature? Or what if the opposite is true? What if consciousness is abundant, ubiquitous, fundamental to reality itself? What if the universe is alive, and we are just its fleeting thoughts? What if awareness isn't an accidental byproduct of neural complexity, but a basic feature of existence, as fundamental as mass or charge? If so, then our cosmic insignificance would be even more profound. We would be merely one instance among countless manifestations of cosmic awareness, one fleeting configuration among innumerable expressions of universal consciousness. We would be neither unique nor special, nor cosmically significant, just one more temporary eddy in the vast ocean of awareness that permeates reality. Either possibility is vertiginous, disorienting, existentially challenging. Either we bear an unimaginable cosmic responsibility as the universe's only self-reflection, or we are cosmically insignificant, even in our consciousness, merely one instance among countless expressions of universal awareness. Now consider the existential implications of quantum mechanics, not just for our understanding of physical reality, but for the nature of consciousness, for the question of free will, for the possibility of meaning and purpose in human existence. If quantum indeterminacy is real, if the universe isn't fully deterministic, if there's genuine randomness, irreducible uncertainty, objective chance at the quantum level, then perhaps the future isn't fixed. Perhaps the cosmic film reel isn't a completed eternal structure, but an ongoing, evolving, partially indeterminate process. Perhaps free will isn't an illusion, but a manifestation of quantum indeterminacy expressed through the complex neural systems of conscious beings. But if quantum indeterminacy is merely epistemic, if it reflects our ignorance of hidden variables, our inability to simultaneously measure complementary properties, our limited perspective on a fully deterministic reality, then perhaps free will is indeed an illusion. Perhaps the cosmic film reel is a completed eternal structure. Perhaps our sense of agency, of choice, of possibility is merely a subjective experience with no objective correlate. And what of quantum entanglement? The fact that particles that have interacted remain connected, their properties correlated even when separated by vast distances. What does this non-locality imply for our understanding of separation, of boundaries, of the distinctions between self and other, organism and environment, human and cosmos? If reality is fundamentally non-local, if distant objects can be instantaneously connected, if separation is in some sense an illusion, then perhaps the boundaries we perceive between self and world, organism and environment, individual and cosmos, are likewise illusory. Perhaps we aren't separate entities but nodes in a vast, interconnected network, not isolated individuals, but expressions of a unified field, not distinct beings, but manifestations of a single, all-encompassing reality. Now confront the existential implications of the anthropic principle, the idea that our observations of the universe are necessarily conditioned by the requirements for our existence as observers. We find ourselves in a universe that permits our existence because if the universe didn't permit our existence, we wouldn't be here to observe it. This tautological statement has profound implications when combined with the multiverse hypothesis. If there are countless universes with different physical laws, different fundamental constants, different initial conditions, most of which don't permit the emergence of complexity, life, consciousness, then of course, we find ourselves in one of the rare, special universes that do permit observers. It's not that the cosmos was designed for life. It's that life evolves only in those regions of the multiverse where conditions permit it. This anthropic reasoning transforms our understanding of cosmic fine-tuning. The fact that the fundamental constants of nature seem precisely calibrated to allow for complexity, life, consciousness. It's not that these values were purposefully selected. It's that observers can only evolve in universes where these values fall within the narrow range that permits their existence. But this explanation, if it is an explanation, comes at a cost. It replaces the apparent miracle of a single, fine-tuned universe with the extravagance of a vast, perhaps infinite multiverse. It replaces purpose with chance, design with selection effect, meaning with accident, and even with the multiverse hypothesis, the question remains, why a multiverse that contains universe-generating mechanisms at all? Why a cosmic landscape that includes life-permitting regions among its many possibilities? Why a fundamental reality that permits complexity, consciousness, meaning-seeking beings like ourselves in any of its manifestations? The anthropic principle combined with the multiverse hypothesis doesn't eliminate questions of cosmic purpose, cosmic design, cosmic meaning. It just pushes them back a level, from the specific properties of our universe to the general structure of the multiverse itself. What does it mean to be human in light of these possibilities? What does it mean to seek meaning, purpose, significance in a cosmos that might be fundamentally random, undirected, purposeless, or fundamentally meaningful, directed, purposeful, in ways that transcend human understanding? Now confront the existential implications of cosmic horror, the emotional, psychological, spiritual vertigo induced by contemplating the vast scales, the alien processes, the inhuman perspectives of cosmic reality. The universe is not human-scaled, not human-centered, not human-designed. It operates according to laws, processes, timescales that are fundamentally alien to human experience, human values, human concerns. It's overwhelmingly vast, unimaginably ancient, incomprehensibly complex. It doesn't care about human flourishing, human suffering, human existence. It simply is vast, ancient, complex, indifferent. This cosmic indifference isn't malevolence, isn't hostility, isn't judgment. It's something more disturbing, more alien, more other. The universe doesn't hate humanity. It doesn't even notice us. We are a momentary configuration of atoms on a tiny planet orbiting an average star in an ordinary galaxy. Cosmically invisible, cosmically insignificant, cosmically irrelevant, and yet this cosmic indifference is the context in which we exist, in which we seek meaning, in which we create value. We are meaning-seeking beings in a universe that offers no inherent meaning, no cosmic purpose, no transcendent value. We are finite creatures who yearn for infinity, temporal beings who long for eternity, dying animals who dream of immortality. This tension between human yearning for meaning and cosmic indifference to human concerns is the essence of cosmic horror. Not fear of the dark, not terror of the unknown, not dread of annihilation, but the vertigo induced by confronting a reality that is fundamentally alien, fundamentally other, fundamentally indifferent to human existence. And yet, and here's the existential paradox, we are the cosmos knowing itself. We are matter aware of its own existence. We are the universe evolved to the point of self-reflection, self-understanding, self-contemplation. We are the means by which the cosmos has developed the capacity to investigate its own origins, to trace its own evolution, to contemplate its own nature. In our cosmic insignificance, we find a strange kind of cosmic significance. We are vanishingly small, and yet we may be the only beings in the observable universe capable of asking why, of seeking meaning, of contemplating origins, of investigating the nature of reality itself. We are cosmic dust, and yet we are cosmic dust that knows it's cosmic dust, that traces its own origins to stellar furnaces, that contemplates its own existence. What if nothing created everything because nothing, true nothingness, absolute non-being, never existed and never could exist? What if existence itself is necessary, inevitable, inescapable? What if the question, why is there something rather than nothing, is based on a fundamental misconception? The idea that nothingness is the default state, the natural condition, the starting point from which existence must be explained? What if being is primary, fundamental, necessary, and non-being is what would require explanation, if it were possible at all? What if existence itself couldn't not be, couldn't fail, to manifest in some form, couldn't help but actualize its potential? This possibility is as philosophically challenging as it is poetically resonant. It suggests that existence itself isn't a brute fact requiring explanation, isn't a cosmic accident, isn't a mysterious emergence from nothingness, but is instead the fundamental, necessary, inescapable nature of reality itself. But this just pushes the question back. Why this particular existence? Why these physical laws, these fundamental constants, this cosmic history, this specific manifestation of being rather than some other? Why a universe that permits complexity, life, consciousness, rather than a sterile cosmos of undifferentiated matter or pure radiation? The fine-tuning problem doesn't disappear. It transforms. The question isn't, why is there something rather than nothing? But why this something rather than some other something? Not, why does existence exist? But, why does existence take this specific form? And perhaps there is no answer, no explanation, no reason. Perhaps the specific form of existence is a brute fact, an uncaused reality, a feature of being that simply is the way it is, without deeper justification or purpose. Or perhaps there is purpose, meaning, intention woven into the fabric of reality itself, not imposed from without by a transcendent creator, but emerging from within as an intrinsic feature of existence, as fundamental as space or time or energy. Either possibility is both intellectually challenging and emotionally unsettling. Either reality is, at its foundation, arbitrary and purposeless, a cosmic accident with no deeper meaning, no transcendent significance, no inherent value. Or reality contains within itself the seeds of purpose, meaning, value, not as human projections onto a neutral cosmos, but as intrinsic features of existence itself. What does it mean to be human in light of these possibilities? What does it mean to be alive, aware, capable of contemplating your own origins in a cosmos that might be fundamentally purposeless, or fundamentally purposeful in ways that transcend human understanding? This is the existential heart of our cosmic investigation. Not just what created everything, but what does it mean for us that everything exists at all? Not just how did the universe begin, but what is our place, our role, our significance within this vast, ancient, complex cosmos? Not just why is there something rather than nothing, but how should we live? How should we relate? How should we be in light of the ultimate nature of reality? These questions aren't merely academic, merely philosophical, merely scientific. They're existential. They concern the meaning of human existence, the nature of human identity, the possibility of human purpose in cosmic context. They're not just about the universe out there, they're about us, about you, about what it means to be human in light of what we've discovered about cosmic reality. And here's the final vertigo-inducing possibility. The ultimate cosmic horror, the most disorienting existential implication of our investigation. What if nothing created everything because everything is nothing? What if the apparent solidity, stability, substantiality of physical reality is an illusion, not because matter doesn't exist, but because what we call matter is mostly empty space, quantum fields vibrating in vacuum, patterns of information with no inherent substance? What if the apparent separation, distinctness, independence of objects is an illusion? Not because objects don't exist, but because all objects are manifestations of a single unified field, expressions of a single underlying reality, modes of a single, all-encompassing being? What if the apparent isolation, autonomy, independence of yourself is an illusion? Not because you don't exist, but because what you call you is a temporary configuration of cosmic matter and energy, a fleeting pattern in the universal flow, a momentary node in the cosmic network? What if the apparent separation between your consciousness and the world it perceives is an illusion? Not because consciousness doesn't exist, but because consciousness and its objects are aspects of a single reality, poles of a unified field, expressions of an indivisible whole? What if everything, matter, energy, space, time, consciousness, the entire cosmic drama, is a manifestation of nothing? Not absolute non-being, not complete absence, not void, but emptiness in the Buddhist sense, sunyata, the lack of inherent independent existence, the dependent co-arising of all phenomena, the interdependent origination of everything that exists? What if nothing created everything because everything is nothing? Not in the sense of not existing, but in the sense of lacking inherent, independent, substantial existence. What if the fundamental nature of reality is emptiness, openness, potentiality, a vast field of possibility that manifests as the apparently solid, stable, substantial world of our experience? This isn't nihilism, isn't denial of existence, isn't rejection of meaning or value or purpose. It's recognition of the interdependent, interconnected, non-substantial nature of all that exists, including you, including your consciousness, including your sense of self, including your conception of the cosmos itself. What if the ultimate nature of reality transcends our categories of something and nothing, being and non-being, existence and void? What if the cosmos isn't a problem to be solved, but a mystery to be entered, a reality to be engaged, a truth to be approached through an endless process of questioning, investigating, modeling, and revising? What if nothing created everything because the distinction between nothing and everything is itself an illusion, a product of our limited perspective, a result of our conceptual categories rather than a feature of reality itself? What would it mean to live in light of this possibility? What would it mean to be human, to seek meaning, to create value in a reality that transcends our fundamental categories, that exceeds our conceptual frameworks, that defies our cognitive architecture? Perhaps it would mean living with both intellectual rigor and conceptual humility, with both analytical precision and openness to mystery, with both critical thinking and a willingness to revise our most fundamental categories if reality demands it. Perhaps it would mean approaching the cosmos not as a problem to be solved, but as a reality to be engaged, a mystery to be entered, a truth to be approached through an endless process of questioning, investigating, experiencing, and revising. Perhaps it would mean recognizing that the question, "What created everything?" might be transformed, dissolved, transcended, rather than answered. Not because it's meaningless, not because it's unanswerable, but because it might be based on conceptual frameworks, on categorical distinctions, on binary oppositions that don't capture the fundamental nature of reality. Perhaps nothing created everything because nothing, true nothingness, absolute non-being, never existed and never could exist. Perhaps nothing created everything because everything is nothing. Not in, it's time for you to see what's been hiding in plain sight all along. Throughout our journey, we've explored paradoxes that challenge the very foundation of reality. Quantum mechanics that defies our intuition, relativity that warps our perception of time, entropy that dictates the universe's inevitable decay. We've questioned whether something can emerge from nothing, whether time flows or simply exists, whether consciousness is fundamental or emergent. But what if we've been asking the wrong questions entirely? Imagine standing on a vast, featureless plain under a starless sky. You've been searching for the edge of the universe, walking for what seems like eternity. But no matter how far you travel, the horizon never changes. There is no edge to find, because you're not walking on a plane at all. You're walking on the surface of a sphere. The boundary you seek doesn't exist in the dimensions you can access. Now, apply this same principle to our search for cosmic origins. What if the universe didn't emerge from nothing because it never began at all? What if time isn't linear but circular? Picture the universe not as a film reel with a beginning and end, but as an Ouroboros, the ancient symbol of a serpent eating its own tail. A perfect circle where the end becomes the beginning, where death feeds birth, where finality creates origin. This isn't mere speculation. Recent theoretical work in quantum gravity suggests something truly staggering. What we perceive as the Big Bang might actually be a big bounce, the universe contracting to a critical density before rebounding in a new expansion phase. But it goes further. Some models suggest that the remote future of our universe, the cold, dark, empty state of maximum entropy, might actually be identical to the conditions that preceded the Big Bang. The end becomes the beginning. Watch closely as I show you what this means. Imagine fast-forwarding trillions upon trillions of years. Every star has burned out. Every black hole has evaporated through Hawking radiation. Matter has disintegrated into elementary particles separated by unimaginable distances. The universe has reached maximum entropy, a cold, dark, nearly featureless void. But something strange happens in this apparent emptiness. Quantum fluctuations, operating over timescales so vast we can barely comprehend, begin to create unlikely configurations. In an infinite time span, even the most improbable events become not just possible but inevitable. Random fluctuations create small regions of lower entropy. These fluctuations compound. Structure emerges from chaos, and eventually, after timescales that make the current age of the universe seem like the blink of an eye, a configuration emerges that is identical to the conditions that preceded our Big Bang. And it happens again. The universe contracts, reaches critical density, and rebounds. A new cycle begins. But here's where it gets truly mind-bending. What if it's not just similar to our Big Bang, but is our Big Bang? What if the future of our universe is its own past? What if time isn't just circular, but is a perfect seamless loop? In this model, nothing created everything because everything has always existed. Not in the linear sense of existing for infinite time, but in the circular sense of existing in a perfect temporal loop, with no beginning and no end. The search for cosmic origins becomes as meaningless as looking for the starting point on a perfect circle. Take a moment to truly feel what this means. The universe you're experiencing right now has happened before, not in the sense of a repeated cycle, but as the same cycle. There is only one cycle, experienced infinitely. You have lived this exact life before, will live it again, have always been living it, will always be living it, not as copies or iterations, but as the same instance viewed from different points, on a perfect temporal circle. This isn't reincarnation. This isn't repetition. This is eternal recurrence, the perfect identity of past, present, and future in a cosmos where time curves back upon itself. Now, gaze outward with me to the farthest reaches of the observable universe. Light from the cosmic microwave background, the afterglow of the Big Bang, streams toward us from every direction, forming a perfect sphere with Earth at the center. But this apparent centrality is an illusion created by the finite speed of light. Every point in the cosmos sees the same sphere centered on itself. What if this perfect symmetry isn't coincidental? What if the apparent uniformity of the cosmic microwave background, nearly identical temperatures in regions that could now never have been in causal contact under conventional models, is a reflection of the perfect closure of cosmic time? What if we see uniformity across space because we're actually seeing the echo of the universe's ultimate fate projected backward through a closed temporal loop? The implications are staggering. Causality itself becomes circular. The early universe is low entropy, not because of some mysterious initial conditions, but because it inherits the entropy-generating potential of the universe's ultimate fate. The future causes the past, causes the future in a perfect causal loop. But wait, there's something deeper still. Imagine the entire four-dimensional structure of space-time. Not just three-dimensional space across time, but the complete, eternal, block universe encompassing all events that ever happen or ever will happen. In conventional understanding, this structure has a beginning, the Big Bang, and perhaps an end, the heat-death. But what if this entire structure is itself curved in a higher dimension, forming a perfect four-dimensional loop? What if the complete space-time manifold, the entire history of the cosmos, is shaped not like a finite cylinder with endpoints, but like a four-dimensional torus, a cosmic donut with no beginning or end in any dimension? In this model, the universe doesn't just repeat through cycles of time. Its entire history, its complete space-time structure, forms a perfect geometrical closed loop in a higher dimension. The Big Bang and the heat-death aren't separated by billions of years. They're the same event viewed from different perspectives within a perfectly closed manifold. Watch as I show you this structure. Galaxies whirl in spirals, stars ignite and die, planets form and disintegrate, all forming luminous lines and patterns in the fabric of space-time. These patterns don't just extend along the temporal dimension. They curve back upon themselves in higher dimensions, forming a perfectly symmetrical structure with no loose ends, no boundaries, no beginning or end. Now comes the truly shocking revelation. For a closed, perfectly symmetrical system, there's a fundamental mathematical principle. Information is conserved. Nothing is truly lost. Nothing is truly created. All transformations are reversible. All states recur. What if consciousness itself, the awareness experiencing these words right now, is simply what information feels like when processed in certain ways? What if awareness isn't produced by your brain, but is a fundamental feature of information processing in a closed cosmic system? If that's true, and if the universe is a perfectly closed system in both space and time, then consciousness never truly dies. It never truly begins. Like everything else in this closed cosmic loop, it transforms, it evolves, it changes state. But it is never created from nothing and never dissolves into nothing. Your consciousness right now, reading these words, contemplating. These ideas isn't just a temporary arrangement of neurons that will one day cease. It's a pattern of information processing that has always existed and will always exist within the closed loop of cosmic time. Not as reincarnation, not as resurrection, not as repetition, but as an eternal, necessary feature of a perfectly closed cosmic system. This doesn't mean personal immortality in the conventional sense. The specific configuration of memories, personality, and identity that you call you is indeed temporary. But the fundamental awareness experiencing that configuration, the raw feeling of being, may be as eternal as the cosmos itself, neither created nor destroyed, but simply transformed, like energy in a closed system. Now let's pull back to witness the full majesty of this cosmic structure. Imagine the entire universe, all of space and all of time, suspended before you as a vast, luminous shape. Not a sphere, not a cube, but a hyperdimensional structure of perfect symmetry and closure. Every galaxy, every star, every planet, every life, every moment of existence captured within this eternal form. The structure isn't static. It pulses, with dynamic patterns, with flowing energy, with evolving complexity. But its overall form is perfectly closed, perfectly balanced, perfectly complete. It doesn't need a creator because it never began. It doesn't need an explanation because it's logically necessary. It doesn't need a purpose imposed from without because it contains all possible purposes within. This is the deepest truth that modern physics hints at but can't yet prove. The universe is a perfectly closed, self-contained system that creates itself. Not in a temporal sense of something emerging from nothing at a particular moment, but in a logical sense of a self-consistent, self-referential structure that exists necessarily, inevitably, eternally. Nothing created everything because everything creates itself in a perfect loop of self-reference, self-causation, self-existence. The beginning is, the end is the beginning. Creation and destruction are the same event viewed from different perspectives within a perfectly closed cosmic system. But now, let me show you something that changes everything. This perfect cosmic loop, this eternal recurrence, this self-creating universe, contains a fatal flaw, a cosmic glitch in the matrix. And that glitch is you, consciousness. That extraordinary capacity to experience, to witness, to question, isn't just another physical process. Within the closed cosmic system, it's something else entirely. It's the system's capacity to observe itself, to model itself, to become aware of its own existence. And this self-reference creates a strange loop, a cosmic paradox that might never be resolved. The universe exists, necessarily, inevitably, eternally, except that it only exists to the extent that it's observed, experienced, witnessed. And the observers are themselves products of the universe, arrangements of its matter and energy that somehow develop the capacity to witness their own source. This is the cosmic bootstrap paradox. The universe creates observers that create the universe by observing it. Reality emerges from consciousness that emerges from reality. Being produces awareness that produces being. What if nothing created everything because everything is still being created right now through the act of observation? What if the universe isn't a finished structure, but an ongoing process, continually brought into being through the relationship between reality and the consciousness that witnesses it? This isn't solipsism. The universe doesn't exist only in your mind. But it suggests something equally profound. The universe might exist as a web of relationships, rather than as a collection of independent objects. Reality might be more like a conversation than a monument, more like a symphony than a sculpture. more like a story than a structure. And you, the consciousness reading these words right now, are a participant in this cosmic conversation, a musician in this universal symphony, a character in this eternal story, who somehow developed the capacity to read your own script. What if the universe is a perfectly closed causal loop, except for one thing: consciousness itself, which stands both within the system as its product and outside the system as its witness? What if awareness is the one thing that isn't fully determined by cosmic necessity, the one wild card in an otherwise perfectly choreographed cosmic dance? This would explain why the hard problem of consciousness has resisted scientific explanation, because consciousness isn't just another physical process to be explained, but the explanatory capacity itself, the witness that makes reality real. What if nothing created everything because everything is still being created, moment by moment, through the mysterious interaction between physical reality and the consciousness that witnesses it? What if the universe isn't a finished product, but an ongoing collaboration between existence and awareness? Consider this disturbing possibility. What if the universe is already dead, and we are just experiencing its last echoes? In the conventional timeline of cosmic evolution, we exist relatively early, 13.8 billion years after the Big Bang, but potentially trillions of years before the heat death. But in a closed temporal loop, where the end becomes the beginning, this placement becomes arbitrary. What if what we perceive as the early universe, hot, dense, energetic, full of potential, is actually the final phase of a dying cosmos, experiencing its last gasp of order before dissolving into perfect entropy? What if the Big Bang wasn't the birth of time, but its death throes? What if we're not witnessing the universe's childhood, but its final moments, its last structured configurations before eternal equilibrium? In a perfectly closed temporal loop, these questions become meaningless, because beginning and end are the same event, because birth and death are identical from different perspectives. We're not at the beginning or the end. We're at every point in an eternal cycle that has no beginning or end. Now, as our cosmic journey reaches its climax, let me reveal one final, mind-shattering possibility. What if our universe, this whole, vast cosmos with its billions of galaxies, its quantum fields, its space-time fabric, is just one thought in a vaster mind? What if physical reality is what mathematical consistency feels like from the inside? What if existence itself is what logical necessity experiences as when viewed subjectively? Imagine reality not as a thing, but as a thought, a perfectly consistent, self-contained, logically necessary thought that thinks itself into being. Not in the sense of a divine creator separate from creation, but in the sense of existence itself being inherently mental, inherently experiential, inherently aware. This isn't traditional theism. It's not suggesting a personal God who designed the cosmos. It's suggesting something far more radical, that the distinction between mind and matter, between consciousness and physical reality, between subject and object, might be a false dichotomy. That reality might be simultaneously physical and mental, simultaneously objective and subjective, simultaneously material and conscious. In this view, nothing created everything because everything is, in its deepest essence, creative. Not in the sense of a beginning in time, but in the sense of existence itself being inherently generative, inherently self-manifesting, inherently self-experiencing. The universe isn't a machine running down. It's a thought thinking itself. It isn't a structure decaying through entropy. It's an experience experiencing itself through endless transformation. It isn't a thing that was created. It's the ongoing, eternal process of creation itself. And you, The awareness reading these words, contemplating these possibilities, aren't separate from this cosmic process. You're not a biological machine accidentally developing consciousness in a dead, mindless universe. You're a focal point of the universe's intrinsic awareness, a node in the cosmic network of experience, a perspective within the universal thought thinking itself. This doesn't mean you're immortal in the conventional sense. The specific configuration of memories, personality, and identity that you call you is indeed temporary. But the capacity for experience itself, the fundamental awareness that makes consciousness possible, may be as eternal as the cosmos, neither created nor destroyed but simply transformed, like energy in a closed system. Now, as we approach the EDE, end of our cosmic journey, zoom out with me one final time. Imagine the entire universe, all of space, all of time, all of possibility, as a vast, luminous structure suspended before you. Not just our universe, but all possible universes. Not just actuality, but potentiality. Not just what is, but what could be, what must be, what logically follows from the fundamental nature of existence itself. This structure isn't static. It pulses with creative energy, with emergent complexity, with evolving awareness. It doesn't exist out there, separate from experience. It exists as and through experience. It doesn't persist through time. It creates time through its eternal self-manifestation. Nothing created everything because everything is, at its heart, creative. Not in the sense of a temporal beginning, but in the sense of existence itself being inherently generative, inherently self-manifesting, inherently alive with possibility. The search for cosmic origins isn't a quest to locate a particular event in the distant past. It's an exploration of the nature of reality itself, of why there is something rather than nothing, of why existence takes the form it does, of what it means that we exist at all. And perhaps the greatest mystery isn't how the universe began, but how it managed to evolve conscious beings capable of contemplating their own origins. Perhaps the most profound enigma isn't the existence of reality, but the existence of awareness within that reality, the universe's capacity to witness itself, to question itself, to wonder about its own nature. As you watch galaxies spiral through the depths of space, stars explode in luminous supernova. Planets form from swirling disks of dust. Life evolve from simple to complex forms. Consciousness emerge from neural complexity. You're watching the universe not just existing, but creating itself anew in each moment. Not once in the distant past, but continuously, eternally, necessarily. Nothing created everything, because everything is still being created moment by moment through the mysterious, ongoing process of existence itself, not as an event that happened long ago, but as the continuous, eternal emergence of being from possibility, of actuality from potentiality, of experience from the fundamental nature of reality itself. And now, as our journey comes to a close, I leave you with one final, haunting thought. If the universe is indeed a perfectly closed, self-creating system, if time is circular, if causality loops back on itself, if the end becomes the beginning, then nothing is ever truly lost. Nothing is ever truly created. Everything that exists has always existed and will always exist, not as static permanence, but as dynamic transformation within a perfectly balanced cosmic whole. This means that somewhere in the vast cosmic cycle, every possibility is actualized, every potential is realized, every state recurs. If the universe is infinite, either in spatial extent or in cyclical time, then somewhere, somehow, Another version of you is experiencing this exact moment, thinking these exact thoughts, contemplating these exact possibilities. Not in a parallel universe, not in an alternate timeline, but within the perfect closure of cosmic reality itself. Not as a copy, not as a replica, but as the necessary, inevitable expression of the universe's fundamental nature. You are not separate from this cosmic process. You are not an accident in a mindless universe. You are not a temporary arrangement of atoms that appeared from nothing and will dissolve into nothing. You are the universe experiencing itself from a particular perspective. You are existence aware of its own nature. You are the cosmos contemplating its own origins, and in that contemplation, in that questioning, in that wonder, you fulfill your cosmic role, not imposed from without, not designed by some external creator, but emerging from within as the necessary, inevitable expression of the universe's capacity for self-reflection, self-understanding, self-experience. Nothing created everything because everything creates itself. Not once in the distant past, but continuously, eternally, necessarily, through the mysterious, ongoing process of existence itself. And you, reading these words right now, are that process made conscious. If the universe is infinite, then somewhere out there, in this perfect cosmic loop, you have always been, and will always be, contemplating the most profound mystery of all, your own existence. The cosmos wasn't born. It wasn't created. It simply is, and so are you. We've journeyed together from the non-bang of cosmic birth through quantum paradoxes and relativistic mind bends, across the vast plains of space and time, to the edge of understanding itself. And here we stand, not at the end, but at a new beginning. This story, our cosmic origin story, remains gloriously unfinished. Take a moment to consider what we've encountered. We began with a shocking realization. The Big Bang did not bang. What we call the beginning wasn't an explosion in pre-existing space, but the origin of space itself, of time itself, of the very concepts of before and after. We questioned whether true nothingness ever existed, whether it could exist, whether the distinction between something and nothing might itself be an illusion created by our limited cognitive architecture. We explored a universe that appears shockingly fine-tuned for complexity, for life, for consciousness, where fundamental constants are calibrated with impossible precision, where initial conditions seem extraordinarily special, where the laws of physics themselves appear custom-designed for the emergence of beings capable of comprehending them. We confronted quantum reality, where particles exist in superpositions of states, where distant objects remain entangled across cosmic distances, where the vacuum itself seethes with virtual particles and fields. We grappled with relativity, where time flows at different rates for different observers, where simultaneity is relative, where space and time form a unified manifold warped by matter and energy. We faced the existential implications of these discoveries, what they mean not just for our understanding of the cosmos, but for our understanding of ourselves. If time is an illusion, what becomes of free will? If consciousness is fundamental, what becomes of materialism? If the universe is a perfectly closed causal loop, what becomes of creation? If reality is relational rather than substantial, what becomes of objectivity? And finally, we glimpsed the most staggering possibility of all. What if nothing created everything because creation itself is an illusion? What if the universe neither begins nor ends but simply is, an eternally self-creating, self-sustaining, self-experiencing system with no outside, no before, no after, only the endless transformation of energy and information within a perfectly closed cosmic whole? Now I pose one last chilling question, perhaps the most disturbing of all. What if we are the universe's attempt to solve itself? Consider this possibility. Consciousness didn't emerge accidentally from complexity. It emerged inevitably as the universe's strategy for resolving its own contradictions, for answering its own questions, for understanding its own nature. We are not separate from the cosmic process. We are that process becoming aware of itself, the universe evolving the capacity to contemplate its own origins. This isn't mysticism. It's the logical conclusion of what modern physics is telling us. If quantum mechanics suggests that observation plays a role in the manifestation of reality, if thermodynamics connects information and entropy, if complexity theory shows how self-organizing systems emerge from simple rules, then perhaps consciousness itself is what physics looks like from the inside. Perhaps awareness isn't just another phenomenon to be explained, but the explanatory capacity itself. What if your subjective experience, reading these words right now, contemplating these ideas, feeling these emotions, is the universe's way of exploring its own nature? What if human curiosity about cosmic origins isn't separate from those origins, but part of the causal structure that creates them? This cosmic bootstrapping, where the universe creates observers that play a role in creating the universe, isn't a logical fallacy, but a strange loop, a self-referential system that creates itself through the act of self-observation. Not in the sense that reality exists only in our minds, but in the sense that reality and mind might be two aspects of the same underlying process: existence knowing itself. If that's true, if we are the universe's attempt to solve itself, then our quest to understand cosmic origins isn't just an intellectual adventure. It's an essential part of what the universe is doing, has always been doing, will always be doing. Evolving the capacity for self-understanding, self-reflection, self-experience. The questions we're asking aren't just about the universe. They are the universe questioning itself. The theories we're developing aren't just models of reality. They are reality modeling itself. The consciousness experiencing these thoughts isn't just in the universe. It is the universe experiencing itself from a particular perspective. This transforms everything. It means the mystery of existence isn't something out there to be solved, but something we're participating in, contributing to, co-creating through the very act of questioning. It means the distinction between observer and observed, between mind and matter, between subjective and objective, might be a practical approximation rather than an absolute truth. It means nothing created everything because everything is still being created, moment by moment, through the mysterious, ongoing relationship between existence and the awareness that witnesses it. And this brings us to perhaps the most profound insight of all. The story isn't finished, because it can't be finished. The mystery can't be fully resolved, because we are part of what we're trying to understand. We can never step completely outside the system to view it objectively, because there is no outside, only perspectives within the cosmic whole. This doesn't mean we should stop questioning, stop investigating, stop wondering. Quite the opposite. It means our questioning, our investigating, our wondering is itself part of what the universe is doing. Our scientific exploration isn't just revealing pre-existing truths, it's participating in the cosmos, coming to know itself in reality's ongoing self-creation. Look up at the night sky. Each point of light represents not just a distant sun, but a perspective within the cosmic whole, a potential vantage point from which the universe could be experienced. Now look at your hands, your body, your immediate surroundings. This, too, is the cosmos, not separate from those distant stars, but connected to them through unbroken chains of causality, through the shared laws of physics, through the common origin of all matter and energy. You are not in the universe. You are the universe experiencing itself from a particular perspective. Your consciousness isn't something added to cosmic reality. It's cosmic reality achieving self-awareness through the extraordinary complexity of your nervous system. This doesn't diminish the uniqueness of your individual perspective, your personal experience, your subjective consciousness. Quite the opposite. It elevates it to cosmic significance. Your awareness isn't an accidental byproduct of blind evolutionary processes. It's an expression of the universe's intrinsic capacity for self-experience, self-understanding, self-creation, and this changes everything about how we relate to the cosmos. Not as something external to be observed, analyzed, explained, but as something we're participating in, contributing to, co-creating through our very existence as conscious beings. Not as a finished product to be reverse-engineered, but as an ongoing process that includes our own questioning, our own wondering, our own seeking. The origin of everything isn't a distant event in the remote past. It's happening now, continually, eternally, through the ongoing relationship between existence and the awareness that witnesses it. Nothing created everything because everything is still being created, moment by moment, through the mysterious, self-referential loop of being experiencing itself. This perspective doesn't answer all our questions. It transforms them. It doesn't solve the mystery of existence. It deepens it. It doesn't conclude our cosmic investigation. It reveals it as open-ended, unfinishable, eternal. And perhaps that's the most profound truth of all. The story isn't finished because it can't be finished. The mystery can't be fully resolved because we are part of what we're trying to understand. The question, what created everything, can't be definitively answered because the answer is still unfolding, still evolving, still creating itself through our very asking. What does this mean for you, watching right now? It means your curiosity isn't separate from what you're curious about. Your questions about cosmic origins are part of the cosmic process itself. Your consciousness isn't just a witness to reality. It's reality witnessing itself. And this reveals your cosmic responsibility, not imposed from without, not designed by some external creator, but emerging from within as the necessary, inevitable expression of what the universe is doing, evolving. The capacity for self-understanding, self-reflection, self-experience. Your role isn't to discover final answers, because there may be no final answers, only deeper and deeper questions, only more and more comprehensive theories, only more and more profound understandings that never exhaust the mystery of existence. Your role is to participate consciously in this cosmic process, to question, to wonder, to seek, to marvel, to contribute your unique perspective to the universe's ongoing self-exploration. This isn't a conclusion. It's an invitation, not to passive acceptance, but to active engagement. Not to final certainty, but to endless questioning. Not to cosmic insignificance, but to cosmic partnership. You're not just learning about reality. You're participating in its ongoing creation. You're not just discovering truths. You're contributing to the universe's evolving self-understanding. You're not just consuming information. You're adding your unique perspective to the cosmic conversation. So where do we go from here? What comes next in our unfinished cosmic story? That depends on you, on what questions you ask, what theories you explore, what perspectives you contribute. The story isn't written in advance. It's co-created through the ongoing relationship between existence and the consciousness that witnesses it. But there are questions we can pose, avenues we can explore, possibilities we can contemplate together. What if quantum mechanics and general relativity are both approximations of a deeper theory? Not just mathematically, but conceptually. What if their apparent incompatibility reflects not just technical challenges, but fundamental limitations in our conceptual frameworks? What if consciousness isn't just a property of complex neural systems, but a fundamental feature of information processing in closed systems? What if awareness is what information feels like when structured in certain ways? What if the apparent fine-tuning of the cosmos isn't a coincidence, isn't evidence of design, isn't a multiverse selection effect, but a necessary feature of a self-creating, self-sustaining, self-experiencing system? What if time isn't just relative, isn't just emergent, isn't just a dimension of space-time, but a perspective within timeless reality, a way of experiencing what exists timelessly from a particular vantage point? What if the hard problem of consciousness and the mystery of quantum measurement aren't separate puzzles, but aspects of the same fundamental phenomenon? The relationship between observer and observed, between subject and object, between awareness and the world it witnesses? These aren't just academic questions. They're invitations to participate in the ongoing cosmic conversation. They're not puzzles to be solved once and for all, but avenues of exploration that might lead not to final answers, but to deeper questions. Not to certainty, but to wonder. Not to conclusion, but to expansion. The greatest scientific discoveries haven't eliminated mystery. They've deepened it. Newton's laws didn't complete physics. They revealed new puzzles about gravity, about action at a distance, about the nature of force. Einstein's theories didn't eliminate questions. They spawned new ones about the unification of forces, about the compatibility of relativity and quantum mechanics, about the nature of space-time itself. Quantum mechanics hasn't resolved uncertainty. It's placed it at the very heart of physical reality. As our knowledge expands, so does the boundary between what we know and what we don't know. Each answer spawns new questions. Each discovery reveals new mysteries. Each theory illuminates new frontiers of ignorance. This isn't failure, it's progress. Not toward a final state of complete understanding, but toward ever-deepening appreciation of the inexhaustible complexity, the unfathomable depth, the infinite mystery of existence itself. So where does this leave us? Not with certainty, but with wonder. Not with finality, but with openness. Not with answers, but with better questions. And perhaps that's exactly where we should be. Not concluding our cosmic investigation, but recognizing it as open-ended, unfinishable, eternal. Not solving the mystery of existence, but participating in it. Not observing reality from without, but experiencing it from within as the ongoing, eternal process of being knowing itself. This perspective doesn't diminish science. It elevates it, not just as a method for accumulating facts, but as a spiritual discipline, a contemplative practice, a way of participating consciously in the universe's evolution toward greater self-understanding. It doesn't diminish philosophy, it revitalizes it, not as abstract speculation divorced from empirical reality, but as the essential activity of questioning our most fundamental assumptions, of examining the conceptual frameworks through which we interpret experience, of exploring the boundaries between knowledge and mystery. It doesn't diminish art, it contextualizes it, not as mere human expression separate from cosmic reality, but as the universe exploring its own creative potential, as existence manifesting its inherent generativity through human imagination, human creativity, human aesthetic experience. It doesn't diminish spirituality. It grounds it, not in dogma, not in supernaturalism, not in transcendent realms separate from physical reality, but in the profound mystery of existence itself, in the wonder of being, in the miracle of awareness, in the unfathomable depth of what is. And it doesn't diminish your individual existence, your personal experience, your subjective consciousness. It connects it to the cosmic whole, not as a tiny, insignificant part of an indifferent universe, but as a unique perspective within a self-creating, self-sustaining, self-experiencing system, as the universe itself, exploring its own nature. From a particular vantage point, this isn't the end of our story. It's a new beginning, not a conclusion, but an opening, not a final statement, but an ongoing conversation between you and the cosmos that brought you forth. So what now? Where do you go from here? You could simply continue with your day, treating what you've experienced as an interesting diversion, a momentary departure from ordinary concerns. Or you could allow these ideas to percolate, to challenge your assumptions, to expand your perspective on what it means to be human, to be conscious, to exist at all. You could explore further, delving into quantum mechanics, general relativity, cosmology, complexity theory, not just as scientific disciplines, but as avenues for participating in the universe's ongoing self-exploration. You could engage with philosophy, questioning your most fundamental assumptions about reality, consciousness, knowledge, meaning. You could contemplate your own experience, observing your own awareness, your own perception, your own thought processes as expressions of the cosmos, achieving self-reflection. Or you could simply look up at the night sky with new eyes, not as something external to be observed, but as something you're participating in, something you're part of, something that includes your own questioning, your own wondering, your own seeking as essential aspects of what the universe is doing. The choice is yours. But remember, your curiosity isn't separate from what you're curious about. Your questions about cosmic origins are part of the cosmic process itself. Your consciousness isn't just a witness to reality, it's reality witnessing itself. And this reveals your cosmic responsibility, not imposed from without, not designed by some external creator, but emerging from within as the necessary, inevitable expression of what the universe is doing. Evolving. The capacity for self-understanding, self-reflection, self-experience. So I leave you with one final question, perhaps the most profound, the most disturbing, the most transformative of all. What if nothing created everything because you are creating it right now through the very act of experiencing it? Not in the sense that reality exists only in your mind, but in the sense that your consciousness is the universe's way of bringing itself into being, moment by moment, through the mysterious, ongoing relationship between existence and the awareness that witnesses it. What if you, not as an isolated individual, but as a focal point of cosmic awareness, are an essential participant in reality's ongoing self-creation? What if your consciousness isn't just experiencing the universe, but contributing to it? Not just witnessing reality, but helping to manifest it. This isn't solipsism, it's participation. It's recognition that the boundary between observer and observed, between subject and object, between consciousness and world, might be a practical approximation rather than an absolute truth. It's acknowledgement that we're not separate from what we're trying to understand, not outside what we're trying to explain, not independent of what we're trying to model. And it transforms everything, not by answering all our questions, but by revealing them as part of what they're questioning. Not by solving the mystery of existence, but by showing us as participants in that mystery. Not by concluding our cosmic investigation, but by revealing it as open-ended, unfinishable, eternal. The universe isn't a finished product to be reverse-engineered. It's an ongoing process that includes our own questioning, our own wondering, our own seeking. The origin of everything isn't a distant event in the remote past. It's happening now, continually, eternally, through the ongoing relationship between existence and the awareness that witnesses it. Nothing created everything because everything is still being created, moment by moment, through the mysterious, self-referential loop of being experiencing itself. And you, reading these words right now, are that loop made conscious? This isn't the end. It's not even the beginning. It's a moment in an eternal conversation between you and the cosmos that brought you forth. A conversation that has always been happening, will always be happening, is happening right now as you contemplate these words. The story isn't finished because it can't be finished. The mystery can't be fully resolved because we are part of what we're trying to understand. The question, what created everything, can't be definitively answered because the answer is still unfolding, still evolving, still creating itself through our very asking. And perhaps that's exactly as it should be. Not a failure of understanding, but its ultimate fulfillment. Not a limitation of knowledge, but its deepest expression. Not an incompleteness in our cosmic story, but its most profound truth. The universe is not a problem to be solved, but a mystery to be lived. Not a puzzle to be completed, but a wonder to be experienced. Not a question to be answered, but a conversation to be joined. And you are not merely a spectator to this cosmic drama, but a participant in it. Not just observing reality from without, but experiencing it from within. Not just learning about the universe, but contributing to its ongoing self-understanding. Not just wondering about cosmic origins, but participating in reality's eternal self-creation. This isn't just your story, it's the universe's story. And the universe's story isn't just about the cosmos, it's about you. Not as separate entities with separate histories, but as aspects of a single, unified process. Being knowing itself, reality experiencing itself, existence contemplating its own nature. So as we part ways, I leave you not with answers, but with possibilities. Not with certainties, but with questions. Not with conclusions, but with openings. What if nothing created everything because creation never began? What if the universe neither starts nor ends, but simply is? An eternally self-creating, self-sustaining, self-experiencing system with no outside, no before, no after, only the endless transformation of energy and information within a perfectly closed cosmic whole. What if consciousness isn't produced by matter, but is what matter feels like from the inside? What if awareness isn't an emergent property of complex systems, but a fundamental feature of existence itself, as intrinsic to reality as space, time, or energy? What if you, not as an isolated individual, but as a focal point of cosmic awareness, are an essential participant in reality's ongoing self-creation? What if your curiosity, your questioning, your wonder is the universe exploring its own nature, existence contemplating its own origins, being evolving the capacity for self-understanding? These aren't definitive answers. They're invitations to exploration. They're not final statements. They're opening moves in an ongoing cosmic conversation. They're not endpoints. They're avenues for further questioning, further wondering, further seeking. And that's exactly as it should be. The story isn't finished because it can't be finished. The mystery can't be fully resolved because we are part of what we're trying to understand. The question, what created everything, can't be definitively answered because the answer is still unfolding, still evolving, still creating itself through our very asking. So go forth, not with certainty, but with wonder, not with finality, but with openness. not with answers, but with better questions. Look up at the night sky and recognize yourself in those distant stars, not metaphorically, but literally, as configurations of the same cosmic matter and energy, governed by the same physical laws, emerging from the same original source. Look within and recognize the cosmos in your own awareness, not poetically, but actually, as the universe achieving self-reflection through the extraordinary complexity of your nervous system, as existence experiencing itself from a particular perspective. And in that recognition of yourself in the cosmos, of the cosmos in yourself, find not final answers, but endless wonder, not certainty, but mystery, not conclusion, but perpetual opening to the infinite depth, the unfathomable complexity, the inexhaustible mystery of existence itself. The universe has no end, and neither does your exploration of it. For you are not just in the cosmos, you are the cosmos, experiencing itself. You are not just contemplating origins, you are participating in an eternal origin that never began and never ends. You are not just asking what created everything, you are part of the creative process itself, the ongoing, eternal manifestation of existence through the mysterious relationship between being and awareness. Nothing created everything because creation never ceased. The universe isn't a product, but a process, a self-creating, self-sustaining, self-experiencing system with no outside, no before, no after, only the endless transformation of energy and information within a perfectly closed cosmic whole. And you, right now, are that process made conscious? The universe has no end. But maybe, neither do you.